agree with any of these papers, like if we want to take like a moral stance here, but like certainly these papers are interesting and worth talking about. I think I'm live on YouTube, so let me go ahead and get started now. Hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. So today we got a real spicy, I don't know how to put it. This is sometimes when you're reading papers, most of the time when you're reading papers, right? Like there isn't too much to it. Like you read the paper, you learn something, you move on. But every now and again, there's drama. Right? There's drama related to the papers, people's interpretations of papers, this type of thing. And just today, I found this paper that was published about a month ago now, a couple weeks ago on June 10th, called The Illusion of Thinking, right? And it is a comment on this paper from Apple, which is The Illusion of Thinking, understanding the strengths and limitations of reasoning models via the lens of problem complexity, right? So long story short, Apple engineers published this paper talking about the limits of AI reasoning models, right? Fair enough. I mean, we've all known that AI reasoning models are limited in some ways, and it's good that we have people testing to see what those limits are. That's great. Then OpenAI and Anthropic, you can see their affiliations here. Why is this in erase mode? Anyway, you can see their affiliations here. Both of them came up saying, actually, you're wrong. And here's why you're wrong. Now, there's a couple things to keep in mind here. Like just off the get-go, look over here. June 10th, 2025 versus June 7th, 2025. I'm not going to make any moralistic judgments about the papers themselves, at least not now. I might start ranting at some point during the process of reviewing these articles. But there is no way you can even get an appropriate rebuttal in 3 days. Like that's not going to happen, right? So like there is reason for me to believe that this response, though it may have some accurate, like there might be a lot of accuracy to it, like there might be a good reason for this response, it probably will not be a response to the entire paper. Rather, what I'm probably seeing is that the response to the initial paper is probably just picking at very specific things that they saw wrong with the methodology, right? That's where we're at. Imagine if the paper is AI generated. Like that is a huge, I don't want to go into that, right? I don't want to talk about that. It takes me a day just to absorb the text of a paper. Right. This is exactly right. Like there's no way they were able to do anything in 3 days. Just, it's not possible, right? So let's go ahead and start talking about a bunch of different things. First, I have to we have to kind of talk about where we're at. I have to introduce things for the YouTube VOD folks. There's a lot of things to talk about. So first of all, if you are watching this, not live, but as a YouTube VOD, right? You're watching this after the fact, after it's been recorded, which to be honest is probably the majority of people. Here's how things are going to go. What I'm going to do is I'm going to start by doing a very basic introduction, right? So intro, and basically my thoughts. Whoa. Thoughts? I don't know what I was typing, but that was not it. Then we're going to read the papers. And then we're going to conclude, right? That's how things are going to go, right? I will have timestamps to all of this in the like the YouTube bar below. So if you just want to hear the introduction and the conclusion, conclude with an N, Jesus, that's fine, totally fine. I'm going to try to make sure that you guys can do that if that's what you want to do. If you only want to watch the video for 5 minutes, that's fine. However, as someone who really does genuinely enjoy reading papers, I'm hoping that some of that enthusiasm will kind of wear off on you guys as well. Maybe I'm not super enthusiastic about AI as a topic of discussion, but I do love reading papers, and I'm hoping that that will also be enjoyable for you to watch as well. So again, if you're watching the VOD, maybe just the intro and conclusion is enough. If you're here for the live stream, I do hope that you guys have a lot to engage with. Like there's a lot of different avenues to participate while we're going through the paper. Good, so that's kind of where we're at. So first, let's talk about biases, right? And I have to be honest, I have my own biases, right? So just to make sure we're all clear, hello, I'm Dr. James Schloss. I got my PhD at the Okinawa Institute of Science Technology Graduate University back in 2019. Since then, I've been working on and off in the Julia Lab at MIT. Those are it's like the research arm behind the Julia programming language. This means that I have some experience in language design, and you could argue that the thing that I'm working on right now is itself a meta-programming language for GPUs. That's fine. You could argue that like I have some expertise in this area, but keep in mind that during my PhD, though I did GPU simulations of quantum stuff, and during my postdoc, I've done GPU simulations of a bunch of different things, I myself have really stayed out of the generative AI game. Like it's just not something that I've found interesting from a research perspective. And because of that, I haven't really done anything with it. It's not really something that I've like really grappled with. And I also find it at least for me and my use cases, not to be particularly useful. That isn't to say that some people can find it useful. Certainly people in chat have corrected me multiple times and said that AI have made them 2 times as efficient as a developer. And like, that's fine. I've always acknowledged that there are niche cases where AI is useful. But I have an entire video on my thoughts on specifically generative AI, and you can feel free to look at it. It's 40 minutes. So the cliff notes are, 1, I kind of see the entirety of AI as a copyright minefield right now, and for that reason alone, I'm staying out. But even if it weren't a copyright minefield, I feel like there are a lot of people who are really overselling the hype of AI without looking at how the tools are right now. And as the tools are right now, they're certainly not these crazy tools that can do everything, right? There's limitations to the tooling, right? The majority of people who are AI enthusiasts are simply claiming that, like, hey, if AI is this good now, it's going to be even better in the future. But we need to qualify that a bit. We don't have the evidence to support the claim that it will actually be that much better in the future, and we have lots of evidence to support the claim that it's actually getting, decidedly worse. Like we're no longer growing at an exponential rate, and we have plenty of reasons to believe that as well. So, long story short, if you can currently use AI tools in your workflow, then probably that workflow will have some advantage using AI in the future. If you cannot use AI in your workflow right now, there's no reason to believe that it's going to like kick you out of a job just yet. Like it's just like a lot of people are like, there's a lot of hype and there is not enough evidence to support that the hype actually will lead to anything meaningful. So those are my current thoughts on AI, right? That's it. There's a lot more, and you can feel free to look at the video if you really want more information, but long story short, that's where I'm at. I'm kind of just lukewarm, tepid about the entire thing. I don't see it as interesting fundamental theoretical research at this point in time, just because unlike the other thrusts for AI in the past 30 years, this particular thrust hasn't provided any new, like, it's not like, we have gradient descent coming out of this. It's not like we have genetic algorithms coming out of this. It's like these particular methods that are coming out were kind of already known. The only thing now is that we have the hardware to allow for these methods to really shine, whereas we didn't have the hardware before. So it's not like we've seen huge theoretical advancements due to these methods, and it's currently up in the air as to how these will actually benefit the greater research scene as it is. So let's get going from here. So those are my own biases, right? But we do need to talk about the biases of the authors of the paper. Now, I don't normally have to do this, right? Because for the most part, the majority of the research literature is written by academics, people who don't really have a stake in the game that they're playing, right? Like, that's the point of having an academia, like a separate group of people who are doing research. So let's say there's a biologist, if they do a study on, water fluoridation and its activity in preventing tooth decay, right? You can generally trust that. But if that academic is funded by Coca-Cola, well, now we have this conflict of interest at hand, right? And unfortunately, these papers that we're going to read today both have conflicts of interest. I'm just going to write them out right now. So Apple, right? Apple currently is in a kind of weird limbo when it comes to technological development. That is to say, they have been on top of the game in their individual sphere of development for a very long time, right? Basically, everybody has been following the trends of Apple in many different technological spaces. You could argue the M1 Macs were revolutionary for laptops. You could argue the iPhone was revolutionary for smartphones. You could argue so many things about Apple, and you would probably be right. But there's one area where they are currently struggling, and that is AI. It is true that in terms of Apple Intelligence, they are not able to deliver the features as quickly as they would have hoped, and these features are not generally as useful as they would have liked. The same is true, you could say, for Google and Samsung, who are also trying to push AI tools onto their consumers. A lot of times these tools are just not as useful as they wanted them to be, and you can see this even in the commercials, right? Like, it turns out that, like, the general public, though there are some utilities for AI, are struggling to figure out how they would actually use these tools in practice. And Apple Intelligence is one of the core battlegrounds, you could say, for AI versus like everyday people, right? Like, what does your grandmother need AI for? I don't know. This is a question. This is what people are trying to answer. So Apple is in this stage where they recently have been trying to unveil Apple Intelligence, only for it to not exactly be given a warm welcome, as you could say. So in some ways, what they're trying to do is find a scapegoat. They're trying to say, look, we can't do what we want to do because these tools are not as developed as they could be. So that's what they're looking for. They want some legitimate reason as to why their company has not been able to embrace AI as much as it, had wished to in years prior. So that's what they're looking for. And this paper seems to be the perfect, way out. They're like, look, these AI tools can't do this, therefore they're not useful for us. That's kind of why they would write a paper to begin with. So there is definitely some bias on the part of Apple due to like just their nature as a company, right? Usually I don't have to think about this. I don't have to think about the authors and their individual biases outside of like weird nitpicks. But this time I do have to absolutely claim that Apple has had issues with AI currently and has had issues with AI in the past. Now, on the other side, we have Anthropic and OpenAI. And I don't feel like the reason I spent so much time on Apple in this discussion is, how do I put this? Apple, yes, has some biases and has some conflicts of interest here, but Anthropic and OpenAI, whoa, boy, do they have, huge conflicts of interest here. They are literally the companies who are creating AI for people to use. Like there is technically a business partnership between OpenAI and Apple in that like you're using OpenAI in Apple Intelligence, right? And so like all of that stuff, all this conflict of interest I was talking about with Apple kind of pales in comparison to the conflict of interest that we have with Anthropic and OpenAI. Clearly they are going to defend themselves. And as I stated earlier, like this is literally they saw the paper and in 3 days they responded. This shows how incredibly like feverish they were to make sure that this paper was proven wrong, right? Like it shows that they didn't really think about it. They were in such a frenzy to prove the paper wrong that they didn't even create a proper rebuttal. They just said in 3 days, oh, it's false. Here's why. Like it's so quick. Again, there was a discussion here about how the paper might have been AI generated. It's so fast, I feel like maybe it was AI generated. You know what I mean? And in fact, if you look at the acknowledgements, it does say that they are acknowledging OpenAI or acknowledging ChatGPT. And I'm wondering how much of the paper was written by AI. We'll see. We can talk about that as we go further. But the fact of the matter is that both of these companies have conflicts of interest that we have to talk about. In chat. So I tried to raid your channel, but it has raids disabled. Yeah, I have raids disabled. I just don't. On the one hand, I do really appreciate that you were willing to raid my channel on Twitch. For those who don't know, on YouTube, raids are a feature that allow different communities to send their viewers at the end of their stream to another channel. But I have them disabled on my channel because they disrupt the flow of my discussion, and then also like I'm usually not streaming for long enough that the raid is worthwhile. So like basically once people raid, like in 5 or 10 minutes I have to raid someone else, and it adds a lot of social pressure to me as a streamer to like find someone else to raid and all this kind of stuff. So it's just not the way in which I like to approach live streaming. I understand that in terms of community buildment and stuff, community engagement, all that kind of stuff, it's totally worthwhile and valid. It's just for my particular streaming style, it doesn't quite fit. So, what is federated learning Apple keeps talking about? Wait, I don't know, actually. It takes me days. So, shared memory on... What is this? Was a Banger Apple product? Oh, actually, yeah. Anything to do with, like... Look, there's no doubt that Apple has been doing great stuff with their M1, M2, M3, M4 chips. Like, there's no question. Like, their hardware is outstanding, right? Okay, so these are biases. These are our conflicts of interest. I'm biased. Apple's biased. Anthropic, OpenAI, everyone is biased. That's totally fair. We have to acknowledge our biases here. So let's start going through and dissecting the papers themselves. Here is my general knowledge of what the paper is. So let's do journal, new page before. So number one, Apple says the following. AI reasoning models are limited in scope. All right, paper number 2. AI bros say, nah dog, that's user error. Okay, and basically what they say is the reason that the initial paper had such problems was not due to fundamental issues with the reasoning models themselves, but because of specific issues that were chosen in the implementation from Anthropic, from OpenAI, from these companies, right? And so they're saying, no, it's not technically an issue with the reasoning model, it's an issue with the experimental implementation. And then they're also saying that, you know, some of these specific tests that you were giving are just too difficult for humans to do anyway. So like, it's not really something, like you gave them impossible tasks, and also, you know, you're testing infrastructure that isn't quite thought out well. Now, I'm just going to go ahead and say it here. Again, I have to say this multiple times. The AI, how do I put this? The AI response paper was written in 3 days, right? So we know that paper number 2 was not exactly, it wasn't given the time to shine in the same way that the first paper was, right? It feels like a rapid response. There's so many things we could say about this paper. But as someone who, I would not say I've done language design, like I am in the Julia GPU ecosystem, I've been in the Julia lab, I've participated in, like I've contributed to most of the GPU libraries in Julia, but I would not say I'm a language designer. But I will say that I can somehow share some of the perspective of someone who does design a language. And if you claim that a language is designed via, or like there is user error in the usage of Julia or something like that, like as a language designer, I know as a fact that there is no such thing as user error. If the user makes an error that you feel like as a developer you would do something differently, like you feel like, oh, you should have used Julia in this way, and it's weird that the user used it in this way, well, that's not the fault of the user. It's the fault of the language design encouraging behavior that was not necessarily like correct for that particular workflow. You know what I mean? And so anytime someone tells me that, oh, this was user error, I kind of, I take that with a grain of salt, because I personally believe that user error doesn't really exist in the traditional sense. It's not like, certainly there are old grandmothers who are probably using technology wrong. That's totally fair. But like, if you are a trained professional, such as the Apple developers here, and you're trying to figure out how to use technology, I mean, you're literally Apple engineers. Like, you should know what you're doing. So the claim that Apple is somehow, Apple developers, Apple engineers have some form of user error when using OpenAI, I feel like that claim is going to fall, like it's going to fall on deaf ears. Like no one's going to listen to that. Avocado, hey, thank you, Avocado Violet, so much for the, I guess, a shout out or whatever you did. I really do appreciate that you like the content enough that you're willing to send people over. Also, I do hope your stream was okay. What do you think of the next big AI breakthrough? Is it even quantum? Oh no, we're not talking about that. We're not talking about quantum AI. You're sticking two scams together. I'm not going to do that. Okay, so let's go ahead and start reading the papers. We're going to start with the abstracts, and then we're going to go through and kind of pick apart those claims before going into the papers themselves. Now, let me open up the papers here because you'll notice something immediately. This paper says it's 30 pages long. It is not 30 pages long. It's about 10 pages long and then a lot of appendices. This is typically what you'll see for a lot of higher impact journals. What you typically do is you will basically have a short you'll have an abstract, and then you'll have a short paper, and then you qualify all your claims in the appendices, right? This is typically what happens. Now, again, I've made the claim multiple times before. This next paper that was written in 3 days cannot possibly contest all of the claims made in the original paper, right? That is one thing we have to acknowledge here, right? So this is not going to be a perfect response, and I'm sure that these companies are working on a response right now. I'm sure that's what's happening behind the scenes. But this paper, on the other hand, I think it's like 4 or 5 pages with very few references, right? And so just looking at these two claims side by side, I don't think is a fair comparison. I think what we have to do is we have to just take these at face value, right? We know that the first paper had plenty of time and energy put into it. The second paper was a rapid response from companies who were trying to save face, right? So with that in mind, we have to, in some sense, overly analyze the first paper and kind of like see the second paper as like an idealistic vision of what they wanted to say. You know what I mean? Like we have to like take the second paper with a grain of salt, right? And the first paper as well, due to the biases that I said before, but these are different timescales is all I'm trying to say. So let's go and go through the abstract. And one thing I do actually want to point out here is the author, right? So the paper 1 and paper 2 are linked in the description on YouTube. So you should be able to find them, no problem. Let's read paper, discuss equations and evaluation. So we're going to go through and we're just going to read these, right? Before starting, I'm going to, no, don't say we need cryptocurrency powered by AI blockchain. What on earth are you talking about, man? Okay, so before going into this, I want to say the following. Again, we have all the authors' names, right? And I will say this. One of the first authors, right here, is technically an intern at Apple, okay? Ordinarily, I would not make this claim. I would not say this matters, right? Because, of course, there are so many other people on this. It's 1, 2, 3, 4, 5, 6. There's 6 other people here. But again, as someone who's overly criticizing this article, because again, I know there are biases on the part of Apple, and I know there are biases on the part of OpenAI and Anthropic as well, we need to acknowledge that these authors could have their own biases. And being an intern at Apple, I don't know what I want to look at these authors and see where their papers have been in the past few years. Now, again, when we're talking about Apple versus OpenAI in terms of their research patterns, right, I have to also acknowledge that in general, when I see a paper from Apple, as much as I don't trust Apple's marketing strategy, I don't trust them as a company because I just think they do some really filthy things when it comes to consumer behavior. I do acknowledge that a lot of their papers are quite good, specifically the papers when it comes to like cybersecurity and stuff like this. They have a track record of publishing papers that I generally feel, maybe I don't agree with completely, but I do feel are at least very well, like they have all their T's crossed and I's dotted, right? The same thing is true for like NVIDIA and AMD and these other companies. I don't agree with all these companies' business practices, but I can stand by a good paper. And a lot of the times the NVIDIA papers are at least good, right? They at least will give me some information I didn't have before and stuff like that. So generally, again, Apple is fine when it comes to its publication history. Now, Anthropic and OpenAI, in my mind, simply because they're new to the scene, do not have as much experience in pushing what you can do research-wise. And so their papers are not as, like, it's kind of like comparing the work of, a full tenured professor versus the work of a postdoc who just finished a PhD, right? In terms of timescales here, right? And so usually the papers that I'm reading from Anthropic and OpenAI are just not quite as well polished as the ones from Apple. And keep in mind that Apple, if I remember correctly, were one of the original people who funded Pixar, if I remember, and Pixar papers are some of the best in the business for computer graphics. So I might be incredibly biased in just my belief that, Apple has a good research arm to begin with. So when I'm calling out these authors here, all I'm saying is that, like, there might be some bias here, and the fact that this person is an intern, they could be an undergraduate or something, like, we might be comparing, like, someone's undergraduate research thesis, and this could be something where, like, again, I don't know, I need to look at these people and look at their publication history, but it could be a case where we're looking at someone's undergraduate research thesis, and we're, like, really diving into it and treating it like it's like some crazy, like paradigm shift for AI or something like this. That's not, this is what, we just need to keep this in mind as we're going further. Oh, what is this? Quantum blockchain for AI federated learning. What are we talking about here? Well, Apple hates AI, so they tried to have negative propaganda probably. What did Apple invent when it comes to AI? So again, you're right. Again, I mentioned these in the biases before. Like, Apple is inherently biased against AI, whereas OpenAI and Anthropic are very clearly biased for AI. And I will also state the following, in that, like, I would love if these were done by third-party people, like someone in academia, like someone from MIT or not even MIT. I just said MIT because that's where I'm from, but, like, maybe from, I don't know, anywhere, like University of Kentucky, just someone who is not directly involved in this process. That's what I want. It's just really hard to find unbiased actors when it comes to AI nowadays, simply because just everyone has an opinion, even if they don't need to. Okay, so we're going to start with the illusion of thinking. We're going to read through the abstract, and I'm just going to highlight the things that I think are interesting that we might want to look out for as we continue. I'm going to bring out the highlighter, and we are going to do magenta. Okay, so recent generations of frontier language models have introduced large reasoning models. Okay, that's number one. Keep in mind, I don't actually read that many AI papers, so I'm going to learn a lot as we go along here, that generate detailed thinking processes before providing answers, right? For the record, I believe this is what you need for AI to move on to the next step. Like, you definitely need this. Like, simple questions like, how many words are in the response to this question, have tripped up AI for too long. I don't know if ChatGPT can solve that now, but for the longest time it couldn't, right? And so we do need these higher level reasoning models to progress if that is a goal from AI. So that generate detailed thinking process before providing answers. While these models demonstrate improved performance on reasoning benchmarks, their fundamental capabilities, scaling properties, and limitations remain insufficiently understood. Fair statement. Current evaluations primarily focus on established mathematical and coding benchmarks, emphasizing final answer accuracy. Now, that's important to keep in mind as well. I'm just going to highlight this because I think one of the core claims of this paper are going to be that AI fundamentally fails at certain tests, and we have to acknowledge that these tests could have been specifically chosen as things that they know the AI is bad at. You know what I mean? Like, again, I have specific questions that I know AI can't solve, and therefore I talk about these questions whenever people bring up the limitations of AI, because I know what these are. And these could be similar situations where, like, Apple is specifically bringing up problems that they know these reasoning models suck at, right? However, this evaluation paradigm often suffers from data contamination and does not provide insights into the reasoning trace's structure and quality. In this work, we systematically investigate these gaps with the help of controllable puzzle environments that allow precise manipulation of compositional complexity while maintaining consistent logical structures. So that is a bold claim. Right. So what they're claiming here, and again, you might not have caught this, but what they're claiming here is that the structure in which they have provided these tests, right, the way in which they provided these tests, are inherently going to be useful going forward, right? Because what they're saying is that these tests will allow for better like AI testing in the future. And again, keep in mind, this entire paper is about analyzing the performance of these models. So this paper is doing two things. One, it's actually doing the analysis, and two, is providing a framework to do that analysis with. So these are the two claims that we're trying to piece apart with this paper so far. And these are two very bold claims, right? Let's go here. YouTube chat just introduced a sweet feature, ranking chat interactions. Yeah, what is chat rank? What is this? I have top fans? Well, I mean, I appreciate having top fans, I guess. Also, let me do live chat instead. Because sometimes top chat will knock things out. I find word counting or letter counting is just the wrong problem for the model. Right, I agree with this as well, but that's the point of bringing these up, right? Like, the reason you bring this up is because some people will claim like AI can be generally useful for all things, when in fact you know that's not true, and you can give up a very simple counter example. I bring it up simply because it is one of those very simple things you can say that a lot of people don't know about, you know? Reading an AI paper, if you are under duress using Vim, if you're under duress, use Vim to edit a text file. No. We're still using VI. Expect the next stream in September. Also, Leo's hi. I haven't seen y'all since yesterday. All right. What's the name of the paper? So both these papers are linked in the YouTube chat. The two papers we're looking at are The Illusion of Thinking, Understanding the Strengths and Limitations of Reasoning Models via the Lens of Problem Complexity. And the other one is The Illusion of Thinking. And it's just a comment on the previous paper. Okay. So let's keep going. And again, I do expect you guys to maybe know more than I do about this topic, and I'm really appreciating all the discussion here. So this setup enables the analysis of not only final answers, but also the internal reasoning traces, offering insights into how LRMs think, right? Again, this is also a dubious claim. I'm seeing a lot of dubious claims here just in the first couple sentences, right? And the reason this is dubious is because historically, there has been nobody in the history of humanity, I would say, and again, maybe I'm wrong, that has been able to look inside of any type of deep learning neural network and understand its thought process, right? Because let's face it, it does not think like humans do, and understanding thinking in that way does not make sense. It's best to treat it as a black box, similar to how we treat our mind as a black box, as in things come in, things come out, and we can generally assume that like that process in between is thinking, but when we start analyzing what's happening inside that black box, we don't have like it's hard for us to tell, right? Like, again, I always say humans learn by doing, not by analyzing, whereas ChatGPT models, large language models, these types of things learn by analyzing, overdoing, right? And these would be a significant difference in how these things think, but this is just like a kind of off-the-cuff discussion, right? Like, I don't have deeper understanding of how that black box works outside of like basic Hebbian learning understandings. And like, it usually is not worthwhile to dive into that any deeper, right? Okay, through extensive experimentation across diverse puzzles, we showed that frontier large reasoning models face a complete accuracy collapse beyond certain complexities. Again, this is expected, but we'll talk about why this is... I would expect this, personally, from such models because of just my understanding of AI at this point. But I don't have like any justifiable reason why I believe this. I just believe it makes sense. Like, this is what I would expect to happen with these models. Moreover, they exhibit a counterintuitive scaling limit. Their reasoning effort increases with problem complexity up to a point, then declines despite having adequate token budget. Okay, this is a bold claim that they're actually going to, I know they're going to talk about in the next paper, right? Basically, the next paper claims that, okay, there's no issue with the reasoning model. There's just an issue with the specific implementations from Anthropic and OpenAI. And that's going to be something that I know they're taking issue with in the second paper. By comparing large reasoning models with their standard LLM counterparts under equivalent inference compute, we identify three performance regimes. One, low complexity tasks, where the standard models surprisingly outperform our large reasoning models. A medium complexity task, where additional thinking in large reasoning models demonstrates an advantage. And three, high complexity tasks, where both models experience complete collapse, right? Fair enough. Those seem like three good regimes to identify. We found that large reasoning models have limitations in exact computation. They fail to use explicit algorithms and reason inconsistently across puzzles. We also investigate the reasoning traces in more depth, studying the patterns of explored solutions and analyzing the model's computational behavior, shedding a light onto their strengths, limitations, and ultimately raising crucial questions about their true reasoning capabilities. Okay, so lots of themes here, lots of claims. Let's just go and break down the claims, right? So again, they're claiming to create a framework for testing these reasoning models in the future. They're claiming that after testing, they find a complete collapse after a certain period for these large reasoning models. And they're claiming, well, maybe it's just those two claims is really what we're looking at here. But the reason those two claims are important is because we now move on to the next paper, right? I'm going to read the abstract here too, so we have a good general overview of what we're talking about, right? Analyzing is doing too. Yeah, you're right. Neurons don't think as humans do. You're right. Like I gave a back of the envelope statement here about how humans learn by doing. AI learns by consuming data. I don't remember exactly what I said, but like that is not generally like a that should not be. That's like a rule of thumb. I don't even know why I said that, to be honest. It can't be interpreted rigorously in any way. Let's see. The question actually is. Wait. The question actually is, were the models big enough context were used or not? And does using tools like LLMs write the Python code that makes the calculating the answer? Good work has been done on interpretability. People said something similar about CNNs. Yes. Hold my sparse encoders. Then one guy perturbed the neurals to generate images and maximally activated them to generate hallucination-like images. Don't people face total collapse as well, like multiplying 1,000 by 1,000 digits? I'm sure we'll make a mistake without the tools. Right, I mean, but yeah, you're right. And I do know that in the second paper, again, we're going to read the abstract now. I do know that in the second paper, when we start talking about the total collapse of the models, they specifically say, no, if you were to instead write this in this way, such that you create a code or something like that, instead of like just asking the models to reason about this problem, then it would have done better, right? And the reason this is important is because that is how we deal with this stuff as well. Like if you ask a human to multiply 1,000 by 1,000 digits, it's going to be hard, but it is possible because we have algorithms to do so, right? It's going to suck, but we can do it, right? We know we can do it, and people have done it before. I mean, back in the day, old school supercomputers were literally just rooms full of usually women, but people who were just doing calculations. Back when the initial supercomputers were released, the Cray, maybe not the initial one, maybe Cray 2 is when this happened. Back in Los Alamos, what they would do is they would have the supercomputer do a computation, and then they'd have their room full of people do the calculation as well, and they would see which one was more accurate, and they would always trust the people over the supercomputer at the time because the supercomputer was like, they just did, it's new technology, right? Like you have to verify it somehow, right? And so like maybe we're in this stage here where we're verifying, like we have some old school technology and we're verifying how this new technology can be used in certain limits, blah, blah, blah. My point is that like, when it comes down to like exact usage of AI, we still don't know exactly what those uses are, right? Well, we'll use paper as well, which is a tool, right? I think we should, as a society, seek to accelerate ourselves to Cyberpunk 2077 as fast as possible and hook up ChatGPT to Metasploit as fast as possible to render the internet unusable. I have absolutely no idea about anything that you just said. I don't know. I don't even really know what Cyberpunk 2077 is, except that it's a video game. Like, so I don't know what we're talking about here. Hook up ChatGPT to Metasploit. What is Metasploit? I just, like the other day I learned what Queen was. Like I don't know what I'm talking about here, guys. So Penti, thank you for following 24 minutes ago. Zygon02, thanks for following. Okay, let's keep going. So Shoje et al. 2025 report that large reasoning models exhibit accuracy collapse on planning. Oh, let me also put a magenta highlighter. Oh, magenta. Okay. On planning puzzles beyond certain complexity thresholds, we demonstrate that their findings primarily reflect experimental design limitations rather than fundamental reasoning failures. Okay, that's an important claim that they're claiming in this paper, and it's important to look into that. Again, we're not going to be as thoroughly investigating this one because it came 3 days after the previous papers. So I'm not going to worry so much about, like, I want to more understand the gist of their claims, not the claims, like how they're defending those claims exactly. Our analysis reveals 3 critical issues. 1, the Tower of Hanoi experiments systematically exceed model output token limits at reported failure points, with models explicitly acknowledging these constraints in their outputs. 2, the author's automated evaluation framework fails to distinguish between reasoning failures and practical constraints, leading to misclassification of model capabilities. And 3, most concerningly, their river crossing benchmarks include mathematical impossible instances for n greater than or equal to 6 due to insufficient boat capacity, yet models are scored as failures for not solving these unsolvable problems. We will continue for these, we will control for these experimental artifacts by requesting generating functions instead of exhaustive. That's a typo, isn't it? No, okay. Instead of exhaustive move lists, preliminary experiments across multiple models indicate high accuracy on Tower of Hanoi instances previously reported as complete failures. These findings highlight the importance of careful experimental design when evaluating AI reasoning capabilities. Okay, first of all, that statement obviously is true. Like we need to be more careful about how we're testing. That's kind of the point of the original paper, is to figure out how we are going to do these testing models. Secondly, and the thing that is kind of pissing me off here is that, like, this is not how you go about having a discussion between researchers. That's just not how it happens. When you see a paper on the archive, the reason it's on the archive is because it's unpublished yet, right? And then what you do is you reach out via email and you have an amicable solution, right? The fact that they published a paper 3 days afterwards with literally just, what seems to me to be very basic, like they're nitpicking the paper. They're not fundamentally arguing with the paper's like results in a way. And in fact, I think they're actually saying that the results are kind of valid in other instances, right? And so basically they're saying there's an issue with Tower of Hanoi. There's an issue with the river crossing, which I don't actually know what river crossing is. I should probably know, but I don't. And the author's automated evaluation framework fails to distinguish between reasoning failures and practical constraints, right? So this is a bold claim, though. That one's a bold claim because the other paper is specifically stating that they have thresholds to control for these two results, right? And so this one here is claiming that the paper is fundamentally flawed, whereas the other two are more nitpicks. So this second claim is the one that we're actually going to want to really we really want to drill into that second claim. Whereas the other two, again, are nitpicks, could or could not be accurate depending, but it doesn't change the overall reasoning of the paper, I believe. But 2 is the one we want to actually drill in on. Okay, Metasploit you should Google, but Cyberpunk 2077 is like dystopian incorporation controlled future, like essentially worst possible outcome of you will own nothing and be happy. I completely agree. So basically he goes today. I don't know what we're talking about anymore. Okay, so first things first, we're going to go through the original paper and we're going to start talking about it, okay? Again, if you're watching the VOD and you've gotten this far, first of all, I appreciate you. I appreciate that you're here. Second of all, we're reading papers here, right? And I do acknowledge if you're you're watching the VOD and you're looking at this after the fact, look, you can skip forward. We will go through the papers and we will go through the conclusion. However, if you're here live, I really appreciate you being here because this is where we start going into the fun part, I would say, of research. I genuinely love reading papers. And though, again, I'm kind of tepid about AI and I don't really have very deep thoughts about it, I do love reading papers. And I'm hoping that this process of reading this paper will kind of inspire you guys to read papers as well. And so I'm hoping that you guys can we can kind of bounce ideas back and forth and talk about things as we go through this. One of the things that I've been wanting to do on my channel for a while is an actual literature review session where we just go through papers. I've done it once before with a poetry analysis, ironically also for an AI paper, and a couple other things as well. But I just really like the idea of opening up research to as many people as possible, and this is one key way in which we can do that. Finally, third point, it is hot! Jesus! I'm sweating like crazy. It's 30-something here in Barcelona, which is not that hot, but in this room, it's 2 degrees hotter, and so it's just, I'm sweating, guys. Cyberpunk is just a genre originating from books from early 1980, theorizing the potential of the internet and AI. The game is one of many stories. I knew what Cyberpunk was, but I didn't know Cyberpunk. I only know about Cyberpunk 2077 from basic things. I like to read papers as well. We're close, but not quite there yet. We still have working farmland and ecosystem isn't destroyed to the point that real meat isn't widely available and corporations aren't allowed to publicly kill people and get away with it. Okay. I mean, let's keep going. I don't want to talk about the state of the US at this point. You have too many clothes on you. I'm not going to take clothes off. Look, just for the right, look. I think you don't understand. Right now, I've got 40 people watching on Twitch, and I've got 12 people on YouTube, right? That's 50 people in the room. I'm not going to take my clothes off with 50 people in the room, okay? That's not going to happen. I go swimming fairly regularly, and sometimes there are more than 50 people in the room, but that's when you're swimming, not when you're talking about AI, Yeah, so not today. Maybe tomorrow, yeah? Two t-shirts, one for sweat and one for not. Okay, so let's go through. So large language models have recently evolved to include specialized variants explicitly designed for reasoning tasks. Large reasoning models, such as OpenAI's O1, O3, DeepSeek R1, Claude 3.7, Sonnet Thinking, and Gemini Thinking. These models are new artifacts characterized by their thinking mechanisms, such as a long chain of thought, with the self-reflection, and have demonstrated promising results across various reasoning benchmarks. Now, here's my first question, guys. As someone who, again, doesn't read as many AI papers as maybe I should, considering its relevance in society today, again, I've openly mentioned that I'm not into these papers as much as other areas of research. What fundamentally is the difference between an LLM and an LRM? Is there something, maybe just give me, maybe I just look at the Wikipedia article here. Large reasoning model. I just want to know what is the difference. I understand, LLMs in a sense, right? How some large language models, specifically reasoning language models, share information among their input previous layers based on their outputs or subsequent layers. Okay, so this is literally it is an abstraction that allows for the model to learn from the immediate frame before, is essentially what we're what we're dealing with here, right? So a large reasoning model is like, in a sense, you have a neural network and then you've got a deep neural network. And this is kind of like the extension of large language models to being deep large language models, if that makes sense. So it's something like this, right? They talk to themselves, right? No difference, lingo and jargon. They talk to themselves. If my money is correct, LRM, aka SR, is basically make the model think before outputting, kind of like say things to yourself. Sure, that makes sense. I would believe that. Okay. Also, this person says, like a psychiatric patient, but for the record, I talk to myself all the time. So like maybe I am a psychiatric patient, but I don't think it's necessarily wrong to talk to yourself. I think that's totally fine. By the way, hello, Hanif and anyone else here. We do I'm not doing bathtub stream, guys. Why is anyone? Okay, let's go through. For the most part, name one. Boeing, you have 2 t-shirts. How did this go from AI to taking your clothes off? I don't know. Someone mentioned it. I'm pretty sure the whistleblower put 2 bullets in the back of his head. Okay. Let's not talk about this. LLMs deal purely with text, I think. Transformer models learn from themselves. They talk to themselves. What about hot tub? Okay, outside of the tinfoil conspiracy, so we don't know for a fact that they did it. Okay, I'm not getting into that in chat. I'm sorry. I will willingly talk about taking off my clothes, but I'm not talking about conspiracies or things like this. This is kind of way too far out the scope. One OpenAI researcher who was in conflict when he with the company was also found dead. Okay, let's keep going. I don't want to talk about this. Okay, good. So I have a vague understanding of the difference between LLMs and LRMs, namely that LRMs, again, just talk to themselves. They allow for higher level reasoning by basically, again, feeding the output into the input, like basically chaining the thoughts together, right? I think I get that. That might be why mechanisms such as long chain of thought is mentioned here, because that's how it works. I get it. With self-reflection, have demonstrated promising results across various reasoning benchmarks. Now, where is the paper here? This here is where I want a citation. Am I wrong to want a citation there? Like, I actually do really want a citation right here, right about there, with their and demonstrate promising results across various reasoning benchmarks. Do I have to go to these individual papers here and here? Is that what I have to do for these large reasoning models? All right, we're gonna have to put a pin on that one because I do want to actually learn more about like what their differences are and stuff like that, but that's fine. We'll just keep going. Their emergence suggests a potential paradigm shift in how large language model systems approach complex reasoning and problem-solving tasks, with some researchers proposing them as significant steps towards more general artificial intelligence and capabilities. I'm sure that's what OpenAI is doing. Right. Okay, there is an issue here, which indicates that this paper is largely not AI generated. Despite these claims and performance advancements, the fundamental benefits and limitations of large reasoning models remain insufficiently understood. Critical questions still persist. Are these models capable of generalizable reasoning, or are they leveraging different forms of pattern matching? Again, that means citation 6 is probably one that I want to look at later, and I might just go ahead and go down and circle that one and see what it says. Did I just freeze myself? I think I just froze myself. What happened? All right, let's go down. Citation 6 is what I'm looking at. Understanding the limitations of mathematical reasoning and large language models. So this one might be worthwhile looking into. I'm just going to go ahead and highlight this bad boy here, like so. All right, let's go back up. All right, let's keep going. Good. How does their performance scale with increasing problem complexity? How do they compare to their non-thinking standard LLM counterparts when provided with the same inference token compute? And most importantly, what are the inherent limitations of current reasoning approaches, and what improvements might be necessary to advance toward more robust reasoning capabilities? Again, another typo here, which is kind of a little bit embarrassing on the side of Apple, but that's okay. We believe the lack of systematic analyses investigating these questions is due to limitations in current evaluation paradigms. Fair enough. Existing evaluations predominantly focus on established mathematical encoding benchmarks, which, while valuable, often suffer from data contamination issues and do not allow for controlled experimental conditions across different settings and complexities. So there's a couple claims here hidden in this statement, which are interesting. So one is that they focus on established mathematical encoding benchmarks, right? And so one subtle subclaim of this particular sentence is that, and again, this is, I need to state this correctly, so let me think about this, is that these are inherently biased towards the AI performance, right? That's, I think, what they're claiming here. I don't think I stated that correctly, but they're claiming that there is somehow an inherent bias in these benchmarks, right? And you can kind of imagine that, because when it comes to AI's utility and like the broader scope, for the most part, like the only areas in which AI is like really sinking its teeth into, like people are actively encouraged to use AI is in programming, right? Basically, the other areas are not as, they're not really as gripping for utility and stuff like that. Like there's certainly scammers who are creating AI art and stuff like this online, but really programmers are the ones who are saying like, this is actually increasing my productivity and this is a useful tool. Outside of that, most people are kind of like, well, there's utility, but generative AI is not as useful as like computer vision or other types of AI. So for these reasons, you could argue that there is some inherent bias in these tests. And one thing they're trying to do in this paper is to create a new testing framework that does not have these inherent biases. That's fair. Let's see. Typos are watermarks for humans. That is kind of a true statement. Playing Doom, hey Gibbous. All right, let's read here. Fundamentally, LLMs and LRMs are the same architecture-wise. The big difference is the existence of being thinking and end thinking tokens. I want to learn more about that. Thank you. My memory is correct. Okay, so let's keep going. The output of LLM between those two tokens is not shown to the user, and is some sort of scratchpad that the LLM uses. Okay, fair enough. There has recently been a paper showing that large reasoning models are just more efficient samplers, i.e. anything you get from a large reasoning model, you could also get by resampling the base LLM. That's an interesting claim, I think. Okay, again, as someone who's kind of outside of this research, I think that's an interesting claim. So, which, while valuable, often suffer from data contamination issues due to and do not allow for controlled experimental conditions across different settings and complexities. So that's what they're attempting to do here with controlled experimental conditions and different settings complexities. Now, I already have an issue with this claim, and that I've looked at the figures, and I can tell you that like it is kind of weird that they're using like Towers of Hanoi and stuff like this to do this. Like it's equivalent to the die-hard tests, right? Like the die-hard tests are a suite of tests that you can use on a random number generator in order to show how random that random number generator is. And in some sense, I kind of see what this paper is doing is creating a new set of die-hard tests. So let me go there and talk about these tests. So die-hard tests. All right, let's go to die-hard tests. Here we go. So our battery of statistical tests for measuring the quality of random number generator. They were developed by George Marsaglia over several decades and first published in 1995 in a CD-ROM of numbers. So let's talk about these tests because they're actually kind of weird. You've got birthday spacings, you got overlapping permutations, rank of matrices, but then you got monkey tests, count the ones, parking lot test, minimum distance, random spheres test. Basically, like some of these tests, you feel like, okay, like for example, the rank test. Yeah, I feel like there's like some sufficient mathematical reason as to why this is a good test for a random number generator. But the monkey test does sound like one that's not exactly like treat sequences of some numbers as words. Count the overlapping words in a stream. The numbers of words that do not appear should follow a known distribution. The name is based on the infinite monkey theorem. Like it's kind of like, on the one hand, I understand that die-hard tests are some of the best tests in the business for like their utility in understanding how random a random number generator is. On the other hand, like the fact that we're using a infinite monkey theorem test here does kind of like downplay the results. You know what I mean? Like it is a useful analogy, but is it actually the best test to show that we have statistical, you know, it just makes you kind of think about it, right? And that's the same with these, like the Tower of Hanoi stuff in here. It's like, on the one hand, I do understand that, yes, this is a really good test, but also like because it's a toy model, it kind of makes me think that maybe there was a better test they could have used. And I don't know how like useful this will be as a long-term test for LRMs, LLMs, and this type of stuff. So that's something I also want to, I'm just mentioning here. I wonder how that book of random numbers and normal deviations perform on these tests. It seems like a good test that's just named badly. Right, I agree with this. It's just that like, I think when you're reading and you're looking at these tests, like there is something about like just having like, you know, something that you can't really reason about as a human so much. Like that makes me feel like I trust the test more just innately. It's just not because the test is bad, just because like I want to see a test that like doesn't have so much of an analogy. Like I can point to this and be like, here's some p-value that lets me know that like this test is accurate to this effectiveness, this type of stuff. Okay. So moreover, these evaluations do not provide insights into the structure and quality of reasoning traces. To understand the reasoning behavior of these models more rigorously, we need environments that enable controlled experimentation. So there's one claim here that I'm understanding a bit more in depth, and that is that these large reasoning models, right? So they are attempting in this paper at some point to dive into the large reasoning model and better understand how it works, right? How that thinking happens. Ordinarily, this is a fool's errand. It's something that you cannot do with machine learning methods. However, in the specific case of large reasoning models, this might be valuable because the output from a large language model is often human readable. And so if these intermediate steps of large reasoning models are in a sense outputs of large language models, then looking at these intermediate steps actually could provide valuable insight. Right, this is leading me to believe it's not as much of a fool's errand as we thought of before. So in this study, we probe the reasoning mechanisms of frontier large reasoning models through the lens of problem complexity rather than standard benchmarks, i.e. math problems. We adopt controllable puzzle environments that let us vary complexity systematically by adjusting puzzle elements while preserving the core logic and inspect both solutions and internal reasoning. Figure 1 top. These puzzles, 1, offer fine-grained control over complexity, 2, avoid contamination common in established benchmarks, 3, require the explicitly provided rules emphasizing algorithmic reasoning, and 4, support rigorous simulator-based evaluation, enabling precise solution checks and detailed failure analyses. Our empirical investigation reveals several key findings about current large language reasoning models. I've been saying large reasoning models, but it's language reasoning models. No. It does say large reasoning models here, and then it says language reading. What? Am I stupid? I feel like I'm not stupid. This says language reasoning models, right? And this one says large reasoning models, both under the LRM's acronym. What? I have my suspicion that large reasoning models are so overfitted on math problems that instead of actually learning math, they learn how humans design math problems, which is why they're bad in real life tasks. I believe that, if you told me that. Okay, good. So, I feel like I'm stupid here, but you can't use an acronym twice for two different things, right? What's the difference between a language reasoning model and a large reasoning model? Is there a difference? Does this bring me to a different thing? Reasoning language model is different than... No, it's the same. No. What? Probably no difference, right? Probably it's the same thing. All right. This is kind of freaking me out a bit, though. I came into here with not a conscious bias towards the Apple paper because its results seemed valid, and the second paper has like a 3-day delay before its response. But now there's like a lot of like weird... I don't know what word I'm looking for, but like weird things about this paper that make me feel like maybe there wasn't actually as much thought put into this as I would ordinarily have thought. So probably no difference. I just got here, but do you know if the reasoning models can detect sarcasm? Have you tried it? I think even normal LLMs can detect sarcasm. Transformer was the old term. Plus, the context of the paper's publication makes me suspicious that the paper is bad. Right. Well, the thing is, both these papers are going to be bad. Like, we've acknowledged that at the start. Both of them are bad. This is a feud between companies using research as their playing field. That is always going to go south. It's always going to be wrong. There's always, like, we want a third party to do this. Unfortunately, we don't have a third party doing this. We have these people doing this, and it's useful to dive into these, right? A lot of AI papers are lofty. It's a new field, right? But specifically here, like, this particular paper has given me a lot of reasons to be like, did they even look at this paper before it was published? I mean, look at this. Look, they literally have all of this should be indented. This should be indented. They have another indent. They're missing all their indentations, right? Which, fair enough, it's like kind of a LaTeX issue. Like, if you're writing this in LaTeX, which I reasonably they are, then okay, there could be some issue with LaTeX. Maybe that's fine. But like this here, where they have two different variations of LRMs that are both the same, like that's a little bit weird to me. And I don't understand why that happened. There could be some like in-field reason that I don't understand, but it's weird. Yeah, companies arguing over interns, over an intern's paper. That's exactly what's happening here, right? Let's see, what else do we have here? True, but not academically. So the fact is, what I'm poking at here are issues with the paper's construction. I'm not actually poking at issues with the paper's reasoning as of yet. The reason I'm poking at the construction is because a lot of times you'll see poorly constructed papers leading to poorly constructed arguments, right? So that's where I'm at here. I'm trying to decide, like, you know, there was one paper that I read that had outstanding results, but I couldn't believe the results because the figures were literally just screenshots from a LabVIEW notebook or a LabVIEW program, right? I'm like, look, you could have cleaned this up somehow. Like even just putting the results into like Excel and giving me like a different graph is better than like just taking a direct screenshot from your LabVIEW tool. You know, like I just, it's one of those things where like the paper's quality does just inherently impact my understanding of the paper itself and how much I believe the results, right? And again, I don't mean to like attack the authors here, but I do have to acknowledge the fact that, you know, we do know the first author is an intern, although it is shared first authorship with someone who is a full-on Apple employee. And I don't know what the other people are doing. So like, again, this argument that like companies are arguing over an intern paper is kind of what's happening here. So could it be that LRMS instead of LRMS? Large language. Oh, could be something like this, right? Okay, so let's keep going. So first, despite their sophisticated self-reflection mechanism learned through reinforcement learning, these models fail to develop generalizable problem-solving capabilities for planning tasks, with performance collapsing to zero beyond any certain complexity threshold. Second, our comparison between LRMs and standard LLMs under equivalent in inference compute reveals three distinct reasoning regimes. Again, they talked about this before. For simpler, low compositional problems, standard LLMs demonstrate greater efficiency and accuracy. As problem complexity moderately increases, thinking models gain an advantage. Sure, fair enough. I think that's very clear and what you would expect, because reasoning models are specifically aimed at these kind of like moderate complexity problems, right? Things that are one step above what a typical LLM could do, right? Fair enough. So that should be the expected result. When problems reach high complexity with longer compositional depth, both model types experience complete performance collapse, right? Again, we do know that this is a claim that they're specifically arguing against in the second paper. There's something really weird about this paper that I can't quite put my finger on. Like the font is weird. There's something about it. Notably, near the collapse point, LRMs begin reducing their reasoning effort, measured by inference times tokens. Now that's an interesting point. They reduce their reasoning effort, which I guess I could understand why they might do this, right? In the same way as like when you're doing a parallelized problem, right? Like at some point, like if this problem just can't effectively use its threads, but it still needs some compute to happen, like certain threads will be idle where other threads are not. So there could be some parallelization issue. So despite operating well below generation length limits, this suggests a fundamental inference time scaling limitation in large reasoning models, reason capabilities relative to problem complexity. So that, to me, is going to be a hard claim to fight against if they do properly justify it in this paper. Like I genuinely believe that's going to be hard for them to compete against, right? It's the same thing as like, you know, like how do you deal with parallelism at scale, right? Like at some point you're going to have one thread that's doing all the work and other threads that are not, right? What do you can do like work stealing and stuff like that, but it's a very hard problem to get right. And it's one of those things that, okay, sure, the opposing team could argue that this is an experimental or like an engineering problem to be solved. But we know from history that like, if it is similar to the problem that we see in parallelism, you know, resource sharing, you know, this type of stuff, thread stealing, work stealing, whatever it's called, like this is a hard problem that we haven't figured out for the past 30 years. We have no reason to believe that they're going to figure it out with AI. You know, like it's one of those things where like, yeah, sure, we could argue that this is an engineering failure. That's fine. But then you also have to justify that this engineering failure can actually be overcome, you know, because there is a huge difference between theoretical like ideas and experimental implementation. And sometimes the experimental implementation is impossible, even if the theory is sound, right? And I think this is, that's my point. My point is this could be a hard thing to argue against. Okay. Wouldn't you be able to put in to ChatGPT to tell it to format better? Maybe, but I mean, the formatting are like weird little issues here and there, like things that don't ultimately affect the paper itself. And I'm actually kind of happy to see in a sense, because it means that at the very least, this wasn't massaged by, well, maybe it was massaged by a tool. Like this whole like large language reasoning model versus large reasoning model makes me feel like there was some LLM or some sort of ChatGPT-like thing, at least glossing the results over. I feel like that could be true. I'm not entirely sure, but let's keep going. Which paper is this, if you don't mind? So the paper is called The Illusion of Thinking, Understanding the Strengths and Limitations of Reasoning Models. And the next paper that we're looking at is The Illusion of Thinking, right? So just Google The Illusion of Thinking, you're going to find it. Let's keep going. Finally, our analysis of intermediate reasoning traces or thoughts. Don't pick. Reveal complexity-dependent patterns. In simpler problems, don't pick. In simpler problems, reasoning models often identify correct solutions early, but inefficiently continue exploring incorrect alternatives, an overthinking phenomenon. At moderate complexity, correct solutions emerge only after the extensive exploration of incorrect paths. That's an interesting claim. So correct solutions emerge only after extensive exploration of incorrect paths. Again, that is how we think as well, just for the record. We do think through the process of continually refining our own thoughts. So I do believe that this is possible. Their argument here is, though, that I guess their argument is that this type of reasoning should only happen at large complexity tasks, not at moderate complexity tasks. I think that's the claim that they're trying to make here. So not the title, it says in the title bar. What does the title bar say? AI sucks.pdf? I had to name it something that I'd remember. I gotta be honest something. Here's something about papers that just, it drives me mad, right? On the one hand, I do acknowledge that specifically for this stream and a lot of other things, it is totally valid and worthwhile for me to have a PDF to annotate. I get that. There's a lot of advantages to having PDF. One of the reasons I got my phone and the way that I have is because I wanted one with this thing so that I could do paper annotation, right? But I have one core issue with that. No matter how hard I try, I've never been able to find a way to categorize the papers in which where I can find them easily after the fact, right? Just a huge stack of papers sitting on my desk is always easier to filter through than whatever the heck I'm doing with PDFs. I can never find a good way in order to store them. In principle, I should be able to, because I should be able to Control F through things, but somehow my brain doesn't work that way, and I really just want to search through and find a particular figure. It's like when you're reading a textbook, right? There was a time when I was 5 years removed from a class. It was AP US History, right? And my sister was going through AP US History. I guess it was 3 years removed. And she asked me a question and said, "Do you remember this?" And not only did I remember the answer to her question, but I remembered the exact placement in the book and the picture that was to the left of it, right? Because that's just how my brain works. I recognize the visual imagery and the structure of the page helps me remember things a little bit better, and that's kind of lost with PDFs and stuff like that. Long story short, I don't know why I'm going into this. I suck at naming. I suck at this. I cannot figure a way to manage files as opposed to managing papers, and I love physical papers. And in a sense, I wish I would have done this on physical paper, but that's beyond the point. Okay, the title, it says in the title bar. Yeah, maybe. I always have this question: if LLM's output is based on human input, how is its grammar and spelling almost always 100% perfect? Because the argument would be that the majority of people majority of things it learned off of was post-published, that is to say, edited work. You know what I mean? And so if it is edited work, then that edited work has mostly correct grammar, is what you would imagine. AI sucks. Let's save Apple stock value.pdf. Yeah, look, I'm not, again, I don't know what I'm arguing for. I don't feel like I'm arguing for anything with going through this. Not a fan of programs like Zotero. I haven't found them useful. It's not that I'm not, I like having physical paper, I think is what I've learned. Is that paper that debunks SR thinking? So the hypothesis is reasoning length correlates with problem complexity linearly, right? I'm not sure. That's also something I need to learn. Did you read the title of the paper? Reinformant trailing made the spelling correct post-training thing. Right, okay, so let's keep going. Beyond a certain complexity threshold, models completely fail to find correct solutions. This indicates LRMs possess a limited self-correlation capabilities that, while valuable, reveal fundamental inefficiencies and clear scaling limitations. All right, let me get some water. So keep in mind we're on page 3 here. And really, this is not that long of a paper. I think it's 10 pages long. So we're kind of halfway through this in a way. So these findings highlight both the strengths and limitations of existing large reasoning models, raising questions about the nature of reasoning in these systems with important implications for their design and deployment. Our key contributions are: 1, we present the current evaluation paradigms of large reasoning models on established math benchmarks and design a controlled experimental testbed by leveraging algorithmic puzzle environments that enable controllable experimentation with respect to problem complexity. Fair, that's what we need. 2, we show that state-of-the-art large large reasoning models, O3 Mini, DeepSeek, blah, 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 still fail to develop generalizable problem-solving capabilities, with accuracy ultimately collapsing to zero beyond certain complexities across different environments. 3, we find that there exists a scaling limit in large reasoning models, reasoning effort with respect to problem complexity, evidenced by the counterintuitive decreased trend in the thinking tokens after a complexity point. Again, this to me is their biggest claim. This is their biggest actual claim that they're making in this paper. We question the current evaluation paradigm based on final accuracy and extend our evaluation to intermediate solutions of thinking traces with the help of deterministic puzzle simulators. Our analysis reveals that as problem complexity increases, correct solutions systematically emerge at a later positions in thinking compared to incorrect ones. I think that's fair. I don't see that as a problem. Providing quantitative insights into the self-correction mechanisms within large reasoning models. Okay, that's what they're trying to eke out here. They're trying to say that, look, this allows us to uniquely see how these reasoning models work. That's great. We uncover surprising limitations of large reasoning models' ability to perform exact computation, including their failure to benefit from explicit algorithms and their inconsistent reasoning across puzzle types. Now, I've been saying large reasoning models. I know language reasoning models is apparently also a valid term. It is what it is. Okay, let's go here. Post-training thing, classic long-term memory problem. How long has it been? 20 years. When I say we reached another AI wall, this was one part of it. I think I understand where you're coming from here with the AI walls. Okay, so related works, reasoning in model languages. So this is actually a very important thing that I want to look at. So keep in mind, I've said this before, and I'm going to say it again. When you read research papers, right? Part of the goal of reading a research paper is to understand that specific paper. But the overall goal of reading a research paper is to not only read that one paper, but to understand what you don't understand so you can start diving into the research literature and start figuring out these little pieces and create that network of papers that you want to, like basically building your own textbook to understand the topic, right? And so one of the most important parts of any paper is its bibliography, specifically when you're starting to learn, right? Because what you need to do is you need to go through, and anytime there's a claim that you don't necessarily agree with or you're questioning in the paper, because again, every single sentence in a paper is itself a claim, then whenever these claims come up, you should be able to find the results either in that paper itself or in some other paper in the bibliography. So that's why these related works are actually very important. They help you understand at least the author's understanding of their work in context, right? Now keep in mind, I'm a big fan of papers that have large bibliographies. It makes me feel like at the very least there was some thought put into its relationship with the rest of the literature. And keep in mind, because this paper was written presumably in more than 3 days, the bibliography here is much greater than the bibliography of the rebuttal paper. And keep in mind, again, that it's not a rebuttal paper, it's just a response, blah, blah, blah. There's so many things to say, but let's keep going. So, what do we have? Well, you write the program and run the program. You don't run the program in your mind. So yeah, okay. So, large language models undergo multiple costly training phases using vast amounts of training data. This is a true statement. People have argued, I don't know how true this is, they were actually basically out of training data for these models. Not yet, but pretty close. While these large language models demonstrate promising language understanding with strong compression capabilities, their intelligence and reasoning abilities remain a critical topic of scientific debate. Now, this means 7 and 8 might be references that I want to look at. The reason I want to look at these is because, for me, and I'm probably not going to do them on this stream, by the way, we've already been talking for an hour and we have the rest of this paper and another paper to get through. But the reason I want to highlight these in particular is that, like, how do I put this? I actually don't know what the industry thinks are problems and if those problems correlate to the things I think are problems. You know what I mean? Like, for example, this discussion here about understanding with strong compression capabilities, right? Like, basically what they're saying is that, like, we're able to compress data into this semantic reasoning space, which is itself strongly compressed, right? Like there are ways in which we can compress all this data in a format that we can get an easy input and output to, right? Like, you know, diffusion models are different than large language models and what the difference is. These are all like nuances that, not nuances, these are big things that I want to learn more about if I were to dive into this particular type of research, but I just don't know at this point in time. So this is where I'd probably pause and I would look at these papers. But for the sake of this stream, we're going to keep going and we're going to assume, we're going to make some assumptions, which is never good and not usually the way in which I read papers. But again, I would highlight 7 and 8 as papers that I probably would want to read. So earlier iterations of LLMs exhibited poor performance on reasoning benchmarks. Again, these specific benchmarks I want to know about, and these should have been cited up top as well. To address these shortcomings, several approaches have been explored with the common theme among them being scaling. both the training data and test time computation. For instance, generating a chain of thought and incorporating self-verification. Right? These are both very valid things that are necessary. I'm interested to see if these papers here are from companies or if they're from individual scholars, right? This is one issue that I have, and that like basically all the research when it's related to anything with AI is so far on the industrial side that I'm having trouble believing any of the results, because again, I don't trust industrial research as much as I trust just some standalone professor, some standalone lab in University of Kentucky. You know what I mean? Like, I want third parties to be doing this research, not first parties, because the first parties are always going to be biased, as we've stated multiple times before. Consider the compression ratio of model training data is incredible. I agree with this. My argument was that compression, I think what I should have said there is that there are questions as to whether the semantic reasoning space is itself a good method for the compression. Like, so for example, one way in which you can poison, we'll say, I'm messing up my words here, but there are tools, Nightshade and Glaze, that allow you for you to specifically poison the semantic reasoning space, right? I know this is true. And the question is, could there be other methods of this compression that would not allow for such poisoning, stuff like this? This is what I'm talking about. Reproducibility is also a big issue, right? Which is why, again, how do I put this? When it comes to AI output, right? Again, you don't own the output. It has to be public domain, and you're supposed to, in principle, provide that public domainness, as well. So like if you generate something from an LLM, technically the stuff that's generated should also be in the public domain as a separate entity from the thing that you're publishing. No one does this, but technically that's how it is legally right now. Okay, let's go ahead and read here. Transform paper came out of industry. This is true, right? I need to be a little bit less biased towards industry research, but I am saying in this particular case, when there is a lot of financial interest involved, specifically with people trying to figure out the utility of AI for general use, this is one of those things that it's hard to trust, right? The current race is towards reasoning, so it can analyze complex problems. I know I used DeepSeek to calculate 7 times 7 determinant. There were not round numbers. The result was correct, so yeah. Text poisoning has been done. It's called, Spamton Speak? Anthropic won the landmark copyright in the trading. No, I don't think they won it, though. I think what happened was, which copyright are we talking about, actually? I don't actually know what you're referring to. Yeah, I don't actually know which one you're referring to. How many levels deep do you usually go when doing that? I actually don't know. It depends on the paper and how much I want to learn. But you're talking about like how many papers I'll read. It could be, I don't know. Sometimes it's just surface level, just papers immediately, from that paper, or it's deeper. By the way, in general, should one assume you never ignore a question, therefore ignore a question, therefore repeat it? Usually I get most things, but sometimes I don't. I don't know. I don't know what you should. Could you tell me the case? I'm interested in this case. So what case did they win? What case did they lose? Sorry, just give me like a case number. I don't know if you can link on YouTube. I know you can link on Twitch. So prior to the final answer, let's see. However, obtaining high quality and scalable chain of thought data is quite expensive due to its scarcity. Another line of research focuses on compensating for the lack of supervised data by teaching models to think more effectively through supervised learning and reinforcement learning. Yep, that to me sounds much... Look, you're not going to find the data for chain of thought. You're going to have to... Chain of thought thinking, I don't know. You're going to have to do supervised learning and reinforcement learning. That's the only way forward I see. A notable open source example of these improvements is DeepSeek R1, which demonstrates that applying, what is RL again in this case? Reinforcement learning must be it. They just didn't give applying reinforcement learning with a verifiable rewards can significantly enhance model performance, matching that of closed models like OpenAI's O1, leading to a new generation of language models referred to as large reasoning models, such as Gemini's Flash Thinking, Claude 3.7 Sonnet Thinking. What a weird way to state that. You have Scraps Twitch VODs for chain of thought data. You have to, yeah, okay, yeah, specifically from me, I guess you get a lot of this. Okay, understanding large reasoning models. Recent studies have explored various aspects of reasoning behavior. Large reasoning models have shown emergent behaviors such as discrepancy between thought traces and final answers, as well as efficiency concerns through what researchers term the overthinking phenomenon. That's interesting. I don't know anything about this. Where models produce verbose, redundant outputs even after finding the solution, creating significant inference computational overhead. Oh, okay. This happens all the time with machine learned. Anything AI does this. Not just large language models and stuff like this. Like every AI model has this problem. Like even like genetic algorithms, if you go too far, will have this problem. Like this is very well known and very understood in the literature. In this work, we systematically analyze how much model thinks with respect to task complexity. Recently, Balloon et al. Demonstrated that in newer large reasoning models, accuracy generally declines when thinking increases in math problems. In contrast, we observe when controlled puzzle environments difficulty passes a certain limit, the model starts to think less, and opposite correlation of thinking and task complexity only happens to some threshold. So that's an interesting claim as well. Basically, what they're trying to say is that we need to... So there's like the thinking, the large language model, then the large reasoning model is essentially adding chains of thought to the large language model, right? And so the argument here is that balance of how long the reasoning chain should be is very dependent on the problem and is itself an open area of research. Cool. There's a length-based bias reward function. Right, exactly. Balloon et al., yeah. Yui et al. Questioned whether reinforcement learning truly elicits novel reasoning patterns and shows PASEC of reasoning versus non-reasoning models converge to the same point. We also observe that in Math 500, PASEC is close to reasoning versus non-reasoning models, but we observe different patterns under medium and high complexity of puzzles, which is not easily observable on established math benchmarks using common evaluations. Okay, fair enough. So the reason they're providing these tools in this specific test suite is to figure out how long that chain of thought needs to be. This makes sense as to why they're creating this test suite. I get it now. Okay, controllable evaluation environments. Unlike earlier studies that focus on mathematical problems to evaluate the reasoning capabilities of language models, this work introducing controllable puzzle environments. These environments allow for precise manipulation of problem complexity while maintaining consistent logical processes, enabling a more rigorous analysis of reasoning patterns and limitations. Controllable environments are not uncommon in the literature. I'm questioning why they needed these citations. Like usually when I see citations, I'm like, yeah, I get it. You need to cite this. But this one, like, is controllable environment a keyword that I did not think about before this point? By the way, Don Vito GG, thanks so much for following a few minutes ago, or last minute, or whatever. However, our primary aim is not to propose a new benchmark. Instead, we use these benchmarks as tools for designing experiments to understand, oh, they're not proposing a new benchmark. Well, that actually would have been the most useful thing that they do in this paper. I'm surprised that they don't want to propose a new benchmark. I don't know why they stopped here. You know, maybe because they need a curator of the benchmarks, and so they don't want to be like, oh, I'm curating these benchmarks in a similar way as the Die-Hard tests are curated. They just want to say, look, we did these things. These could be used for benchmarks down the road. I'm not entirely sure. So instead, we use these benchmarks as tools for designing experiments to understand the reasoning capabilities of language models. A closely related study by Valmiken et al. Demonstrated that O1 models show significant performance improvements compared to previous methods. Our work offers additional insights such as examining pairs of thinking and non-thinking models. Furthermore, we study the reasoning traces of the large reasoning models in more depth, revealing different behaviors across various complexity levels. Are psychologists, neurologists, etc. involved in AI research? Predominantly no, but I'll explain. I can explain exactly where in just a second. Apparently, the Anthropic case was this one. Thank you. I'll take a look. I don't know what PASEC is. Can someone tell me what that one is? I also want to look that one up. And then I want to look PASS at T. This one? Is that how it was? No, that wasn't it. How did they spell it? It was. What is this one? PASEC. Should I know this one? I don't know this one. Is having how calculate the evaluation? Oh, this does not look nice to me. Understanding a human eval. This is what I want. Weird that I didn't see the citation for that one, but maybe I just didn't understand. Let me go here and put this into Google. And let me do, I don't want to do court listener. There's a really good Bart's Z versus Anthropic. So which one was this one? One of the first substantive decisions, analyzing whether the use of copyrighted works to train large language models for generating artificial intelligence services is infringing or fair use. Judge William Alsup issued a split decision in his summary judgment order here. So what was the judgment? Can you give me Quartz fair use analysis. In its fair use analysis, so I've always stated the following. Let me just, before looking at this, I've always stated the following, and that is that when it comes to large language models, I do believe they sufficiently can, in many cases, overcome the barrier to claim for fair use. In many cases, I believe that's true. The argument that I usually make is that, like, that's fair if it's fair use, but fundamentally the artist should have had the right to consent. Like, my argument is always like, look, legally it's in a gray area for two reasons. Not the fair use argument. The fair use argument I think is totally valid. But the two reasons are that, one, you don't own the copyright of the output, which is true. The Copyright Office has never granted copyright of AI, generated AI output to a human entity. That has not happened. And two, again, the people whose data is being used here should have, had some reason to contend. So one is wishful thinking that the laws should have provided this capability. And the other one is a general reality that you don't own the output, right? Those are the two copyright things that I talk about. The fair use argument is, I don't really care one way or another, right? This is one where it's like, generally I do see the argument. I personally think it's derivative work, which is why I think it's a bit scuffy, but like whether or not you can prove that in court is another story, right? Copyright, okay, privacy, bad. Right, so my mind is copyright. So, okay, my mind is, as long as the copyright law, as it is right now, is enshrined, saying that the output of LLMs or any generative AI model is itself public domain, as it currently is, that's a fair enough compromise. I don't mind that one. And also, if we allow users or enforce that users must have like the ability to protect themselves from AI, like as long as these two things are fair, I think it's fine. I don't really want to dive any deeper into this. It's like, okay, fine, it is what it is. I think the fact is that proving that the output of a large language model is a derivative work in court is next to impossible. I don't think that's going to happen very easily. There are certain cases where the like diffusion model, such in the case of Disney versus OpenAI or Anthropic, whatever. I think it's OpenAI. Whatever. So Disney's case has some teeth in that like they're directly creating like Disney caricatures and work, and that's fine. Huge lobbying is happening in favor of AI. See, that's the question. Why is it happening in favor of AI? Because you'd think that almost all these companies hate it. Like Disney has to hate it. The entire but Midjourney is OpenAI, right? Isn't Midjourney owned by OpenAI? Am I wrong? I'm probably wrong about this. This is where I'm stupid. But long story short, Midjourney might be its own thing. Maybe I'm misunderstanding this. Long story short, the lobbying is happening on both sides here. Like there are certain actors who are for AI and certain actors who are against AI. And that's fair. That's how it should be. I think. Well, it's not fair. I think for the most part, if we wanted to protect consumers, like it is very clear that there's like some copyright violation happening, and the protection of consumers would be against AI, but that's not how it works. It's simple. Disney et al. Can make a deal with AI companies regardless of training illegality. That's also probably a fair point. Let's see. I just remembered, wow, what do I have here? I just remember my favorite AI story. When that one AI to generate Doom gameplay was announced, the community was worried that they had scraped all the custom levels and made something that generated new levels, but then it turned out to be something much dumber and less practical. I believe they're involved in considering the morality of AI. They basically hooked an image generation AI to control pad and took it to generate the next frame. Oh no, that sucks. I thought copyright challenges were all based on individual case-by-case basis. I think that's probably true. Disney also uses AI. I think it's complicated. Yeah, the thing is though, it's very difficult, right, to see how Disney can use an AI as a tooling currently exists, right? Like you can kind of see it in intermediate, like even for intermediate frame generation, AI has been proven to be kind of useless. So like when you're creating images and artwork and videos at the scale that Disney is creating, it is quite difficult to see AI being useful in its workflow exactly. But it's hard. It's hard to see. Really, like the only people that are pro AI, like really pro AI, are the AI companies. It's like that's really it. Like, and I don't know. I don't really know who's pushing it, right? The Doom community has a history of having to deal with procedurally generated slop levels. But as an outsider, the massive amount of Doom levels freely available to download was an obvious target, so it's wild that they didn't do that. Morality doesn't matter with money. Disney used it to recreate old actors. That's probably true. I'm probably missing a lot of information here. It's just about clicks and hype, not usability. Lots of companies see AI as something they could theoretically use instead of employees. Employees are expensive and have rights and stuff. Yeah, I see that companies think that, but also like if they understood the tools, they wouldn't think that, Promise is Gen AI used to replace the stock photos, B-rolls, etc. If it got advanced, it can even generate entire movies. Yet I don't think there's any reality that I see the technology moving and that it could create an entire movie. That's very far in the future. I don't see that possible, right? I don't see that possible, right? Coca-Cola uses AI. Yeah, that one sucks. It doesn't even look okay. It looks awful, but whatever. I'm not going to go into there. Let's not talk about this. So, long story short, what was this court case? That's what I want to learn. What was this court case and what was it about? Court listener maybe is what I want. I don't actually know what the best website is to look at. What was this court case about? Lots of companies pretend they will be run with AI just to get more visibility and investment money. Yeah, that's kind of what I'm seeing as well. Look, long story short, very clearly the artistic community hates AI with just a burning, fiery passion. They hate AI, right? Which is fair enough. From their perspective, AI stole all of their work and is using it to make slop, right? I would hate that too. I do hate that. As someone who writes stuff and creates software online, I hate the fact that my code is being used to create code slop. I hate that. Even although some people claim to be 2 times as more effective via AI agents, I get that. Even so, I hate it. I genuinely hate this. That's not what my licenses say, and it feels bad. It feels bad, right? I get that. I totally get this, right? The only group of people that I can see actually getting a net benefit, and by group of people, I don't mean companies, just individuals who say they're getting a net benefit are programmers. They say this thing makes me 2 times more efficient or something like this. People have said that. People said that in chat, right? But it's not, I don't know, we're not at the stage where it's generally useful for everything. Disney Research has some papers about using AI for accelerating rendering. Yeah, that's probably true, because they're trying to figure out how to use it. I don't know. Let's not get distracted. What about translators? Yeah, so translators are the case where generative AI models are, I don't think, the appropriate tool for this. The only reason I say that is from a user's perspective, seeing how Google Translate has actually gotten much worse over the past couple of years, and I can't think of why. I don't know why it's gotten worse in the past 2 years, except that they're probably using some generative AI stuff now that they weren't before. That's the only reason I can think of. But it has, I've seen it gotten worse. It's translation from English to Japanese. I have to modify it all the time. I didn't have to do that when I used to live in Japan. It's translation from English to Spanish. I have to mess up all the time. I have to consistently change. I didn't have to do that before, right? So you want to raise my hand as someone who finds LLMs incredibly useful for a wide variety of tasks, but I don't want to distract from the paper, right? You were actually one of the use cases that I was mentioning, right? You mentioned that it's I think you said 2 times. Someone said 2 times is effective, and I think you agreed with it. I don't remember. I think it was 10x Programmer who said 2 times, and then I think you agreed with that statement. I see that some people are finding utility there. I personally am against it for a lot of different reasons, and it's not personally useful for my own workflows, but there's probably some utility here, right? I am trying to be reasonable about that. It's just that, again, the acknowledgement is that you don't own the copyright of the output, so it can't really be used anything that you're claiming copyright over. That's fine, as long as you don't claim copyright over the final product. Fine, who cares? It's fine. AI is useful for motion tracking, TTS. Yeah, this is true. That's all true. Yep, I 100% acknowledge that. Search engines, I don't agree with that one actually, because I don't agree with search engines as much. I used to agree with it, but I don't agree with that anymore after seeing Google's AI overview constantly being wrong. But I agree obviously for motion tracking, face tracking. But keep in mind, I'm talking about generative AI models here, right? And you're talking about other forms of AI, right? You're talking about, so for motion tracking, this is mainly computer vision. It's not generative AI models, not in the way that we currently conceive of them to be. Text to speech, again, this is kind of more like an NLP type of thing, which could be done this was done for ages, and it doesn't necessarily need a generative model for it. Autocomplete, again, you could argue that autocomplete is the closest analog to what we have with large language models, and it is one of those it's a good infant, it's like a large language model in its infancy, kind of, you could argue. So there's a correlation there, but most of these existed well before large language models. The only one that I can see from that list that people are trying to use large language models for are search engines, which I believe is a bad tool. I don't believe the AI overviews are actually useful for consumers. They also hate when a person reads your work and makes bad work based on it. Or it's just, I also kind of hate that. For example, if I make an argument here on stream, someone takes that argument and says, James Schloss is against all AI. I didn't say that. I definitely didn't say that. There are a whole bunch of really, really good uses. I just happen to think that large language models are overhyped. And very much overhyped in many cases, to the point that like people are seeing it as like a doomsday catastrophe. It's like the end of the world. And for me, I'm like, it's kind of useful in niche situations, but I don't see this as like, a world-ending threat in the same way other people see it as. Personally, I'm just annoyed that all the neural types of AI obscures in my opinion, much cooler old school procedural algorithm. Right. That's used for simpler tasks. So this is also what I agree with here. Like, I genuinely hate that people, like, I've always hated this. This has been a trend in the research literature for the past 20 years, where people have been trying to replace, like, optimization algorithms with AI algorithms. It's like, don't do that. Why are you doing that? You're wasting compute time. You're wasting everything so that you can just, like, throw a deep learning network in there. Like, why did you do this? We already have pretty good PDE solvers. You don't need to use an AI to solve a PDE. We have much better solutions for 99% of tasks. There are a few situations where you could use AI here, but like you shouldn't. You shouldn't. Like, we all know you shouldn't. Researchers know you shouldn't. Like, we've known for decades that you shouldn't. And yet somehow now people are like, oh, we can use AI for this. We can use, it's like that phrase, if you have a hammer, everything's a nail. That's kind of what's happening with AI right now. People are like, oh, like you have like, I don't know how to put it. It's like the hammer is AI, and now everything, you can use AI for everything, but like it's almost never the correct tool, right? It is a tool, but it's almost never the right tool, right? It's different. Yeah, though you did give me an analogy yesterday that I've been thinking about ever since, and actually I spoke to my wife about. So yesterday you said that you used AI for a dinner occasion, right? And like, I mentioned that to my wife, and her first response was, that has to be a joke, right? Like, and I think I do understand where you're coming from, in that it can be useful in some situations. Like, specifically if you have a whole bunch of people with different dietary restrictions, it's hard to come up with something. But also, like, I don't know, even in the non-programming tasks, I can't find myself ever wanting to use AI for this type of stuff, because like the pleasure of cooking, for example, is in like figuring this stuff out. Like, that's the joy, like that's the fun, So it's kind of like, I don't know. Anyway, I'm just saying that like it's one of those things where it's like, I think some people will find utility out of it. I just have to acknowledge that I'm not one of those people, right? And that's fine, as long as that acknowledgement is allowed on both sides. Well, like, I acknowledge I'm never going to use these tools, or I probably will not use these tools unless they get much, 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 much better. Like, literally, flat out, like, I cannot see a reality where I will use these tools. Like, I just can't, right? They are not useful. They are not enjoyable. They're basically taking all the joy out of life. Like, for example, I would never use an AI to read a paper, because reading papers is fun. It's enjoyable. That is the most fun part of my day. So I'm not going to let an AI do that. I'm not going to have an AI tell me what to cook, because figuring out what to cook is again, one of those things that I really enjoy. I'm not going to let an AI program, because that's where I find enjoyment, right? Even if it takes me 2 times as long to write the code, that's totally fine, because now at least I understand the code and I had a good afternoon. You know what I mean? Like, it's kind of like, I don't want AI to do things that I want to do. Like, I'm not going to let someone else do something if I enjoy that, right? But yeah, anyway, let's go here. We're going to get back to the paper in just a second. Let's see. There's a lot here that I missed out on. I'm sorry, I'm rambling too much. We need to get back to the paper. AI seems useful for specialized tasks. Yes, true for non-intern programs. AI is the best redundant and can mess up productive systems. 5 checks. Prime can once wiped his entire disk by copying commands from ChatGPT. Yeah, I can imagine that happening. This batch is the case. Our paper, ranting, AI is super useful every day. I'm using AI daily, and it's super useful and more useful. Using AI is coevolution. Okay, we're getting a little bit far here. There's research that shows that people got dumber more than they rely on AI. We could talk about that paper, but not for today. Actually, when you use them correctly, you get way smarter. The problem is that people use it in most stupid way possible, and it can make you lazy if you're not pushing it beyond that. We could say that not writing assembler by hand makes you stupid as well. Yeah, I'm going to briefly mention that as well. I do understand people are claiming that this is just like the next step in like tools that are available, and that's fine. Like, you're talking to a person who's using VI without syntax highlighting. Like, come on. Like, am I really going to be the person that's arguing for AI? Definitely not. I'm not that guy. But there is an argument that if you use AI correctly, it will make you smarter, and we don't have evidence to support that claim. In a similar fashion, as we only have very small evidence to support the claim that AI is going to make you dumber. Now, these threats that like new tools are going to make you stupid have always existed. When the internet came out, people had this claim. When the printing press came out, people made this claim. Like, it's always been there. Anytime a new technology exists, like, people will go back and be like, oh, this technology will make the new generations dumber. And so like, and to some extent they're right, and to some extent they're wrong. Like, it changes the way in which we think, and sometimes those changes are for the better, sometimes they're for the worse, right? the research is up in the air. We're not entirely sure what to do with them, but it is very clear one thing is true, and that is that using AI when you don't know what you're doing is probably not going to help anyone out, right? You have to handhold it and kind of like make sure it's doing the right thing. Like as long as you're smarter than the AI is generally okay, and that's where we're at. Being smarter means you are doing more work in shorter time. We can agree to disagree on some of these claims. Let's see. So just for the record, I know you were not using it as a joke, and I'm interpreting it very liberally. It's just that my wife's immediate reaction was that it has to be a joke, right? Because she couldn't understand why anyone would do that, right? The human making a derivative work, it's bad, isn't as bad for me compared to using AI to make no effort slop derivative. At least a human put in their effort and work. And it can be seen. Yeah, so like to me, let's imagine that we had a human who directly traced one of my artworks, right? Yeah, that is obviously derivative work. That is obviously copyright infringement. And that's obviously something that, like, you know, if they're using this to make money off of, I could take them to court, right? And yet somehow I am with you in that, like, I'm kind of more okay with that than someone using AI to regenerate work that looks like mine. Somehow that it feels more like I'm more okay with someone directly copying and tracing as opposed to using AI for that. Like, I don't know. I can't explain why. My gut feels different about these two things. It's done because it's easier to get funding if you have AI in your proposal. That's true. That's why everyone combines it with their stuff. I also wouldn't trust an AI reading a paper or writing a recipe since those aren't really easily verifiable outputs, but you would immediately use an AI if it could do something you do not want to do. That's a good question. Would I immediately use an AI if it could do something I did not want to do? And I don't know the answer to that question because I haven't come across that. But maybe it could, right? I can relate anyway. Human-generated music until I die. I'll largely pretty bad at assembler so far. Can't even write. That's a fair point. Don't believe that. I'm surprised it's bad at assembler since there must be plenty of examples and the language is so simple. Yeah, but I think it's that simplicity that kind of bites it in the butt. I don't know for sure, but yeah, exactly. So when like actual real reasoning, like part of the reason we're reading this paper is because we're talking about chains of thoughts and allowing for that real reasoning to happen, right? And like anyway, let's just keep going and saying that, like, yeah, I can imagine assembler being particularly difficult for it to get right. Just because it's so difficult to learn, it's too simple to learn like exact, I don't know. Like, it's not a compiler is what I'm trying to say. I find ChatGPT incredibly useful for integrating tons of scattered information across dozens of websites into a single, very readable, distilled, personalized answer. It also gives me great advice and personal, intimate concerns. And hello, how are you? Do you enjoy doing your taxes? I would use an AI. Well, yeah, I mean, without errors. Like, if the AI could do things without errors, maybe. But in the fact is, this is what I said before. Like, 99% of things that I would, like, how do I put this? 99% of things that AI could do, let's say AI could do my taxes, I feel like I'd rather just have a human do it. I'd rather pay for it. That's one, because I wouldn't trust the AI to do it without errors. But let's say the AI could do it without errors. There are actually probably better services. Like, this is something that, like, taxes aren't hard. You know what I mean? You just have to fill in the blanks. Like, that's it. You fill in the blanks and you're done, right? Like, it's not like anybody doesn't know how to do their taxes. Like, figuring out the exact tax code to put down sometimes is a bit hard, but like literally you're just filling in the boxes. Like, that's all you're doing, right? In which case you're gonna have to fill in basically the same number of boxes with AI versus not AI. I guess there's a world where you just send them all your tax information. Like, if you have a bunch of different sources where it could be useful. Like, there's certain cases where I can imagine that being useful. But yeah, anyway, long story short, like, it's kind of like that hammer and nail thing I said before. Yeah, I could imagine AI being useful here, but even then it's like, I'd probably want something else, you know, if it existed, right? Like, in this theoretical world where there's an AI without errors, there should also be a theoretical world where we have better tax software available, you know? Like, why are we pushing for an AI that could do it instead of like tax software that could do it, you know? And yeah, I agree with Gibbs here. It's like, also the whole tax thing is maybe not exactly the best analogy because there's things around it. If you miss one digit, similar programming. Okay, I really need to get back to the paper, guys. I've been rambling for too long. I wanted to know about this particular case. Specifically, I wanted to know if this was a fair use claim. I'm going to assume it is a fair use claim, so we can just go back to the paper. The reason I brought it up was just because I wanted to know what the fight of this one was. Let's see. You're basically against automation this way. Feed your grocery list to an AI and ask it what the price is. Okay, this seems like a little bit of a back and forth that I don't necessarily condone. If you're so poor that you have a to-do list that you optimized for the wrong thing, I'm not entirely sure what these arguments are for, but just I feel like it's getting a little hot on the YouTube chat, so let's just kind of take a side step, like take a chill pill a little bit over there. Okay, so let's keep going. So again, we were just talking about how this particular paper could be incredibly valuable if it were to provide a new framework for testing, but it seems like that's not actually their goal, which does limit the results a little bit in my mind. Okay, so overall, the promising results from recent large reasoning models raise a critical question: how much have the previously reported limitations of LLMs been improved? Right, that is the question. I agree. That is the core question, right? Because people from OpenAI will have you believe that these changes are so fundamental that they will allow us to reach what they call artificial general intelligence in the near-term future. Like they're talking about like within the year, you know. Whereas from my perspective, I don't know if that's ever going to happen. You know, like again, as I said in one of my videos, I feel like what's going to happen is they're going to get to a certain stage. They're going to claim artificial general intelligence when, for most reasoning applications, it's not quite there yet. Now, I still believe that LLMs are a valuable tool for certain workflows. Like I still believe that. It's just probably not for workflows that I'm willing to do. Like it's just not for me. And that's totally valid. Phones aren't really for me. I don't really use my phone. Like there's so many things that are not for me. Like syntax highlight isn't for me. Like auto suggesting code is not for me. There's so many things that are just not for me. I don't like these things, you know? So it's totally valid to say these are not tools I will use, but they have some use cases for other people, and that's where I live in, right? Order of fair use, signed by judge. Those claims are only a slogan to gather funds. Right, I think that as well, specifically because, you know, OpenAI, these companies, they're not making a profit, right? They're all losing billions of dollars per year. Not all of them, but Anthropic and OpenAI are losing billions of dollars per year. So they have to make a sustainable business model, and right now their business model is basically taking money from venture capitalists who are hoping for a return at some point. That is how a lot of these businesses start, so I'm not saying they're necessarily wrong for doing that, but I am saying like they need sustainability at some point. Turns out that a lot of the sustainability they're trying to get from Congress, which I'm not okay with, but let's not go into that. Okay, so we analyzed how well these large reason models tackle problems of varying complexities and examine the properties and their reasoning processes. Okay, so let's go back to figure 1 up here, because they mentioned it a couple times. So figure 1, top, our setup enables verification of both final answers and intermediate reasoning traces, allowing detailed analysis of model thinking behavior, bottom left and middle. At low complexity, non-thinking models are more accurate and token efficient. Okay, so bottom left and middle. As complexity increases, reasoning models outperform, but require more tokens. I think that's probably fair. Like, I could imagine that's fair. Bottom right, for completely correctly solved cases, Claude 3.7 thinking tends to find answers very early at low complexity and later at higher complexity. In failed cases, it often fixates on an earlier wrong answer, wasting the remaining token budget. Both cases reveal inefficiencies in the reasoning process. Look, this is a classic. That is a classic error with any type of optimization problem, right? That's, you know, local minima. I mean, this is classic. Like, you know, if you find a solution around the local minima problem, you've solved all of humanity's issues, you know? Like, this is an expected result, you know what I mean? So let me take a look at these figures. Again, basically what they're saying is that the accuracy drops to 0 over here. It drops significantly, but the reasoning is still better in basically all cases versus just Claude 3.7 plus thinking. And what is this? In the complexity of number of disks. So this is basically saying that in the cases where it got it wrong, it hyperfixates on an incorrect solution. I'm curious as to how they're like doing accuracy here. Like what does accuracy of 100% mean in a Tower of Hanoi situation? I don't exactly know. So let's just keep reading. I'm sure they'll talk about it later. It's just that they already got it to figure 2, and they didn't actually really talk about what the figures are in the text. So I'm a little bit concerned that this paper is not even really gonna talk about the figures. So currently it's not clear whether the performance enhancements observed in the reinforcement learn-based thinking models are attributable to increased exposure to established mathematical benchmark data, to the significantly greater inference compute allocated to thinking tokens, or reasoning capabilities developed by reinforcement learn-based training. That's not a question. That's not a question. What is this? That was a statement. Due to the significantly... So this is clearly before peer review. Like, that's one thing. Recent studies have explored this question with established math benchmarks by comparing the upper bound capabilities PASIC of reinforcement learned-based thinking models with their non-thinking standard LLM counterparts. Is that a question? To increase, currently it's not clear. Yeah, that's not a question. Okay, they have shown that under equivalent inference token budgets, non-thinking LLMs can eventually reach performance comparable to thinking models on benchmarks like Math 500, AIME 24. We also conducted our comparative analysis of frontier large what models and reasoning models like Claude 3.7 Sonnet and DeepSeek R1 versus V3. Our results, shown in Figure 2, confirm that on the Math 500 dataset, the PASIC performance of thinking models is comparable to their non-thinking counterparts when provided with the same inference token budget. That again is very clear. Like it's an interesting result here that I know was shown before, but it's worth highlighting again here. That they're showing that there isn't so much of an advantage to large reasoning models for the Math 500 dataset. Good. That's something to keep in mind. However, we observe that this performance gap widens on the AIME 24 benchmark. It widens further on AIME 25. This widening gap presents an interpretive challenge. It could be attributed to either one, increasing complexity requirements for more sophisticated reason processes, thus revealing a genuine advantage of the thinking models for more complex problems, or two, reduced data contamination in newer benchmarks. Right. What is the AIME 25? Do people know? Interestingly, human performance on AIME 25 is actually higher than on AIME 24, suggesting that AIME 25 might be less complex. Okay, interesting. Yet models perform worse on AIME 25 than AIME 24, potentially suggesting data contamination during the training of frontier language reasoning models. Given that these non-justified observations and the fact that the mathematical benchmarks do not allow for controlled manipulation of problem complexity, we turn to two puzzle environments that enable more precise and systematic experimentation. Okay, so lots of things to state here that's very important. One is that there was that other paper talking about the human thought processes during when using ChatGPT, right? Basically, in this paper, I don't want to go into all the details. There were three groups. One that was allowed to use ChatGPT, another group that was allowed to use Google search, and another one that was allowed no help, right? And they were asked to do basically SAT, college entrance level questions for written work, right? And they basically checked the brain activity while this is happening, right? Long story short, and the reason this is important to mention, is that the reviewers of the work, they had both human reviewers for the SAT and they had AI reviewers for the SAT's answers, right? And the AI reviewers always reviewed the AI results more favorably, whereas the human reviewers always reviewed the human results more favorably. It just pretty much across the board. There were some exceptions here, but most of the time the AI liked its own writing, whereas the humans liked their own writing, right? And again, this is where the discussion of whether AI is actually like a useful tool for learning comes in, because again, I don't want to dive into this paper because it's new. It's on the archive, similar to this one. But basically they're showing that when you use an AI agent, there's like basically no brain activity. But the most interesting part of that study was that when they had the people who were using nothing, right? They were just using their own brain to solve a question. And they asked those people to then use ChatGPT. That group still had some level of brain activity. Whereas the people who did ChatGPT and moved on to having to write their own responses basically had no brain activity. And the nail in the coffin, as they say, is the fact that basically all of the respondents, when asked to talk about what they had written, could not remember most of what ChatGPT had output, but could always remember what they had output. And this makes sense. Like, again, humans learn by doing, and they didn't do in the case of ChatGPT and this type of stuff. The interesting thing as it relates to this paper is not so much that like, okay, there's this disparity in thought between using AI and not. I don't want to dive into those details here. What I want to dive into is the fact that AI has a preference for things that it already understands, and basically it has a preference for like routine, how do I put this? Like patterns and stuff. So these patterns that it can kind of understand in its own way. Again, we can argue about what that understanding means. That come from AI generated text makes it prefer the AI generated output because it's more of a standard output that it can grok more easily, right? Meanwhile, in the case of human generated stuff, we like the uniqueness and the stuff that makes the stuff that causes us to think about things more deeply. And this is one of the things that cause like differences between AI reasoning and human reasoning to appear at a broader scale. So here, when they're talking about the AIME 25 results and AIME 24 results, they say potentially suggesting that data can have, they say suggesting that AIME might be less complex. That's not necessarily a suggestion that I would buy, given the results of this other paper. I would buy that simply the patterns are less strictly prevalent. They're less easy to understand. The patterns are less patterny. I don't exactly know what I'm saying here. That's what I would believe here. Right. American Invitational Mathematical Examination 25, another math problem data set. It's not clear whether A is because of B or C. Welcome to archive papers. So had O3 fixated on telling me a cross product was reversed, I told it that it was wrong and that I tested reversing it. It was extremely rude and insistent. Yeah, I mean, that's the thing though. Like, I mean, I would bet that everyone using AI in this chat is in the group of people who understand that they need to be smarter than the AI to use it, effectively. To use it well, you've got to, work with it. It is another person that you treat it like another person, with its own like kind of thoughts and reasoning, whatever you want to call it. And like, again, like I said, as long as you're smarter than the AI, you can kind of use it in the right way, right? But like I don't know. It's one of those things where like if you are not smarter than the AI and you're asking it for things that you can't like iterate on, then it becomes a little bit difficult, right? Okay, so code completion. Well, I'm missing so much chat. I think people are dead serious about the AGI claims, right? This is the other thing. Like for me, again, how do I put this? For me, in terms of the AGI claims, the artificial general intelligence claims, I will believe it when I see it. That's number one. But two, I don't think it's a claim that we necessarily need to validate. Like, these tools are already useful for some groups, and that's fine to have the tools as they are. They're useful for some groups. We don't really have to do this whole artificial general intelligence. I don't really care about like its benchmark versus people, because my assumption is that people will always have their own benefits and AI will always have its own benefit. Like it is able to sift through data in a way that we can't as humans. But again, I'm not talking about generative AI models here. I'm talking about like computer vision models and stuff like this. But long story short, what I'm trying to say is that like, we know that AI models generally have utility, and there is almost certainly a utility for generative AI models, though I don't know what it is yet on the research front. It does have economic utility in the fact that some people are using it for some purposes, right? Like, that is a clear thing that is happening right now. So I don't really care about whether it's artificial general intelligence or whatever. I don't really care. Like, it's useful, and that's fine. We can just leave that as is, I feel like I missed a lot of chat here, and I'm not going to be able to catch up. And in the interest of time, I'm probably just going to zoom through. So if there's something you really wanted me to respond to and I did not respond to it, let me know. I'm kind of skimming through right now. So AI can tell when something is AI generated too. Yeah, generally people do better when using their brain. Curious. I mean, right, exactly. It's one of those results that's kind of like null. Like, people who think about it for 2 seconds would be like, oh yeah, very clearly. But it is one of those results that's incredibly useful. We're talking about does AI make you think more or not? It's basically one of those results that's really useful for educators. Like, you kind of need this result to exist, to know how much AI you should be putting in school. Again, my answer is it should be about the same as cell phones. That is to say, basically none, but people need to be aware of their existence, That'll suggest fundamental failure, and they make something that sounds like a human wrote it. Goal that elements are theoretically designed to achieve. Are they designed to achieve that? He said grok. Grok is a word that I love, and I hate the fact that now it's an AI. If large language models are specifically trying to sound like AIs, but maybe I'm misunderstanding that situation. Most are additionally trained to be helpful assistant, so that extra layer of training will make it, at worst, sound like humans in other contexts. Akuno, thanks for following. Really appreciate it. I did mention verifiability before. It's best to assume that AI is wrong unless its correctness can be proven. That's true. I think most people agree with that statement. When I see it respond, I could never know if it was a person or machine. Sometimes I even think someone at the data center is messing with me. See, I don't know how true that is, because every response I've seen from AI is very clearly AI. But also, like, maybe I'm just picking up on stuff. I saw a Reddit post where an LM suggested a mixed bleach with vinegar for a cool cleaning agent would have killed the guy. That's how you make a mustard gas or something. Yeah, right. First of all, I've accidentally done this, and obviously I'm fine, but like, I didn't think about it. And so, like, people are stupid and they might follow it. Grokking is an actual phenomenon in machine learning model optimization. Is it? Grok is just a cool word that I've always used. Like the word delve. I like the word delve, but now whenever I use it, people think I'm an AI. I took a photo of my grocery list in my grocery cart and asked for a double check to see if I missed anything. My brain is notorious for skipping things. I may have some sort of dyslexia, dyscalculia. And I was pleased that the AI worked. I thought I had gotten the list correctly, and so this was a silly exercise, but it actually corrected me. I did miss one item that it simply couldn't see in the cart. Look, that's an interesting utility. I fell 10 minutes behind stream. Oh, yeah, catch up. Delve is an S tier word, no doubt. Yeah, this is the thing, right? Like, there's a lot of words like not, N-A-U-G-H-T, that I like using, but like obviously you can't find utility outside of poetry, so it's I don't know. But despite what that crappy paper says, like AI is uniquely bad at writing poetry. So like we still have that. Like it will write poetry that sounds good, but it's all poetic slop that sounds identical. Like it sounds like it all came from the same author. So, at the very least, we might see a renaissance of narrative poetry in the near future, which would be nice. I love narrative poetry. You can tell it to respond more like a human with mistakes, but I never do that. So when are you making Laos AI? I already, my account used to be called Laos OS, and I never made an operating system. I do have a separate account with AI in its name, but it wasn't artificial intelligent. It was meant because AI is like a character in Psalms 119 that's used all the time, and it was a nod to that. And now everyone, when they see the character, they're like, "Are you AI?" I'm like, "No, the I is for something else. It's just like, it's like a name. It's like it's a name that has both Hebrew meaning and Japanese meaning, and I like it for that reason. That's why. Recently, a dating sim came out where you talk to inanimate objects, and it uses the topic of AI in its social commentary themes. There's a lot of potential in that combination of concepts, and I'm curious how it pulls it off. Let's keep going. Leo's calculator. That's probably not going to happen. So this is the interesting thing: the puzzle environments. Okay. So here are the puzzles that they're giving it, and I'm particularly interested in River Crossing and Tower of Hanoi because these are the two that the other paper are claiming are kind of bogus for various reasons. Oh, we've been at this for a while. Good news is, again, there's a lot of figures coming out where we're pretty close to getting through the paper. The reason I say that is because we're already talking for 2 hours. This is how paper reading goes. It's always very enjoyable and fun, but it does take some time. I acknowledge that. Okay. So we evaluate large reasoning models on 4 controllable puzzles spanning compositional depth, planning, complexity, and distributional settings. The puzzles are defined below and illustrated in Figure 3. Okay, so Tower of Hanoi. I think we all know what the Tower of Hanoi is, but essentially it's like you have a big disk, a small disk, an even smaller disk, and you have to kind of like restructure it in such a way. It's like a classical, like it's the one with the disks, right? Actually, now that I think about it, usually the rule set is you have multiple pegs and you have to like restructure it so that it becomes a tower on the other side. But now I wonder if I actually have been playing the game correctly. Let me read this. We evaluate, okay, so Towers of Hanoi is a puzzle featuring 3 pegs and n disks of different sizes stacked onto the first peg in size order. The goal is to transfer all disks from the first peg to the third peg. Valid movements include moving only 1 disk at a time, taking only the top disk from the peg, and never placing a larger disk on top of the smaller one. The difficulty in this task can be controlled by the number of initial disks, as the minimum number of required moves with n initial disks will be 2 to the n minus 1. However, in this work, we do not grade for optimality of the final solution and only measure the correctness of each move and reaching the target state. Okay, so that's an interesting thing. This work, we do not grade for optimality of the final solution and only measure the correctness of each move in reaching the target state. So the reason that's interesting is because this insinuates 2 things. One, it says that the output of this particular, like the outputs were probably all fine. So there probably means that there was no situation where the AI actually fundamentally failed at this problem. Where it failed was in the intermediate steps, which were maybe not as optimal as they could be. I think that's not necessarily bad. And so I could understand why people would make claims that this isn't as correct as it could be. So checker jumping is a one-dimensional puzzle arranging red checkers, blue checkers, and a single empty space in a line. The objective is to swap the positions of all red and blue checkers, effectively mirroring the initial configuration. Valid movements include sliding a checker into an adjacent empty space or jumping over exactly 1 checker of the opposite color to land in an empty space. No checker can move backwards in the puzzle process. The complexity of this task can be controlled by the number of checkers with 2 to the n checkers. The minimum number of moves required to be 2 n plus 1 squared minus 1. So this is the example here. They have blue and they have red, and they basically have to leap them all over. River crossing is one I don't know. Is a constraint satisfaction planning puzzle involving N actors and their corresponding N agents who must cross a river using a boat. Okay. The goal is to transfer all of 2 to the N individuals from the left bank to the right bank. The boat can carry at most K individuals and cannot travel empty. Invalid situations arise when an actor is in the presence of another agent without their own agent present. As each agent must protect their client from competing agents. The complexity of this task can also be controlled by the number of actor-agent pairs presented. So what's going on here? So we have 2 people, okay, and they have to get across to the other side. Let me read that again. Isn't river crossing the wolf, sheep, lettuce thing? It's a wolf, sheep, lettuce thing. Wait, I need to think about this really quick. So the goal is to transfer all 2 to the N individuals from the left bank to the right bank, okay? Oh, I see. Okay, I think I understand. Let me read this again. The boat can carry at most K individuals and cannot travel empty, right? Invalid situations arrive when an actor is in the presence of another agent without their agent present. So basically, you have to have... I still don't understand river crossing. Yeah, give me a link here. Give me a link. I need to understand this one a bit better. I'm too stupid to understand a children's game. Okay, so what is going on here? The first step that was taken is to let the goat go across the river, as any other actions result in the goat or the cabbage being eaten. Okay, so goat and cabbage, right? So the idea is that we cannot have... Wait. A farmer with a wolf, a goat, and a cabbage must cross a river by boat. The boat can carry only the farmer and a single item. Okay, if left unattended together, the wolf would eat the goat, or the goat would eat the cabbage. The farmer must help them all cross the river without any of them being eaten. Okay, so the idea is that you have a wolf, a goat, and a cabbage must cross a river by boat. Okay, and so the first step must be taken is to let the goat go across the river. Because you can't leave the wolf. The wolf will not eat the cabbage. Okay, and the goat will not eat. So the goat has to go first. When the farmer returns to the original side, he has a choice of either taking the wolf or the cabbage across next. If he takes the wolf across, he would have to return to eat the cabbage, resulting in the wolf eating the goat. If he takes the cabbage across second, he'll need to return the wolf, resulting in the cabbage being eaten by the goat. The dilemma is solved by taking the wolf or the cabbage over and bringing the goat back. I see. So basically, you have to go over and bring one back, and go over and bring one back to make sure that, like, you are not... So you take the goat over, return empty-handed. Take the wolf or cabbage over, return the goat. Take whichever wasn't taken in step 3, return empty-handed, take over the goat. Okay. Right. Because, okay, so the wolf and the cabbage won't eat each other. So you take the goat over. Then you bring over either the cabbage or the wolf, and you take the goat back. And then you bring the wolf back over, and then you take... Okay. And so the difference here with the river crossing is that you've extended this. So it's not just a wolf, a cabbage, and a wolf, a cabbage, and a goat. Is now also what? What is this? It's now an arbitrary number of agents where each time you're going to have to bring... Okay, I'm still not fully getting it, but I'm getting there. Modern LLMs would write a script to solve it. Do you know about the guy who's married to with human kids and also married to an AI? What? What is this? Who dating and married his AI assistant? Modern LLMs would write a script to solve it. Grading on does it get frustrated and grab a whole stack. Claude and ChatGPT can execute scripts as part of reasoning. It's pretty cool. Isn't river crossing sheep lettuce? It is. I asked it probability question solving dice. It made a simulation to supplement its symbolic reasoning pretty good. Here's a variation. The rutabaga will eat the sheep. The wolf will eat the rutabaga, and the sheep will eat the wolf. An old version. Yeah, I think this is what we're talking about. I don't think that's botanically accurate. It's wild rutabaga. Thing is hard about a children's puzzle. I mean, someone married Hatsune Miku. Yeah, but marrying Hatsune Miku actually makes sense because she's like a real character. You know what I mean? Like, I don't know how to put this, but like they did a really good job of personifying that character to the point that like Vocaloid music is its own genre. You know what I mean? Like, this isn't like AI creating slop. This is like a genuinely new character where like basically everybody that makes Hatsune Miku music knows the character and uses it effectively in their music. Like, this is a completely different thing. You know what I mean? Than like recreating another artist's work, like I don't know, like this, I don't know, I feel it's different. There's a number of things you can't leave together, so you must order your trip specifically in a specific way to avoid and lose a condition. I'm guessing when n is greater than 3, more than a goat, cabbage, or wolf, they allow you to take over more than one item at a time. Yeah, I think that's exactly what it is. I think basically you have to transfer the items in such a way that like this cyclical network of like, you know, again, wolf, cabbage, and goat, for example. Like again, the wolf will eat the goat will eat the cabbage does nothing, but you know, it's in there for fun. So I assume there's also this cyclical thing where you have to make sure that like, you know, the final solution, basically, yeah, it's a similar thing where you have to go back and forth with the items, and the boat probably is increasing size, right? I'm gonna keep moving on because I can already see why people might be pretty pissed off at this one, because I could imagine their extension to n items probably was not as accurate as they would have liked, which is fair enough. Like that's probably the criticism of the next paper. So Blocks World is a block stacking puzzle requiring a rearrangement of blocks from an initial configuration into a specified goal configuration. The objective is to find the minimum number of moves needed for this transformation. Valid moves are restricted to the topmost block of any stack, which can be placed either on an empty stack or on top of another block. The complexity in this task can be controlled by the number of blocks present. So I guess this is similar to the Towers of Hanoi in a way, but sure, it is distinctly different. Okay. So most of our experiments are conducted with reasoning models and their non-thinking counterparts, such as Claude 3.7 Sonnet, thinking, non-thinking, DeepSeek R1 versus V3. We chose these models because they allow access to thinking tokens, unlike models such as OpenAI's O series. For experiments focus solely on final accuracy. We also report results on O series models. For Claude 3.7 Sonnet models, we allow the maximum token budget 64K. Similarly, for DeepSeek R1 V3 models on local servers, we allow the maximum length to be up to 64K tokens. For each puzzle instance, we generate 25 samples and report the average performance of each model across them. Comprehensive details of our experimental setup and results are provided in the appendix. So, did they test the AI agent against any puzzles that aren't solved by some linear... Right, this is exactly what I was saying. Like, it feels like variations on the same problem. That's number one, which leads me to believe that this problem was uniquely chosen because it's not very, like AI is not particularly good at this problem, which is not something I should be coming off with. You know, like it's one of those things where I want this test set to be like very uniquely different, each individual test, but they felt very similar, right? And so like, that's one criticism I have. The other criticism is I'm not entirely sure how you increase that river crossing question to n items. I don't know how that would work exactly. So I just need to think about that. But that's like my own thoughts. I don't really know how to do that. But I'm just stupid, I think. And so there's just a bunch of different things. So the weird issues I have with this paper are like, one, there's a whole bunch of typos in it, which is fine. I don't mind the typos too much. It's more formatting issues than anything else. Two, these tests don't feel like they're actually, like they have a sufficient breadth of testing coverage for me to feel confident in accepting the results wholesale. I feel like there needs to be follow-up studies on this one, right? Again, this is great. It's good to know. Keep going. Okay. Motivated by the observations in Figure 2, to systematically investigate the impact of problem complexity on reasoning behavior, we conducted experiments comparing thinking and non-thinking models pairs across our controlled puzzle environments. Our analysis focused on matched pairs of LLMs with identical model backbones, specifically Claude 3.7 Sonnet with and without thinking, and DeepSeek R1 versus V3. In each puzzle, we vary the complexity by manipulating problem sizes n. Sure. Figure 4 presents the accuracy of both model types as a function of problem complexity across all puzzle environments. Complementing this, Figure 5 shows the upper bound performance capabilities PASEC of the model pairs under equivalent inference token compute, average across all puzzles. Extending earlier analyses from mathematical benchmarks, let's see, Figure 2 and the controlled puzzle environments. Results from both of these figures demonstrate that, unlike observations from math, there exists 3 regimes in the behavior of these models with respect to complexity. Okay. These are the regimes that they talked about before. In the first regime, where complexity is low, we observe that non-thinking models are capable to obtain performance comparable to or even better than thinking models with their token efficient inference. In the second regime, with medium complexity, the advantage of reasoning models capable of generating long chain of thought begins to manifest, and the performance gap between model pairs increase. And the most interesting regime is the third regime, where problem complexity is higher than the performance of both models and have collapsed to zero. Results that show that while thinking models delay this collapse, they ultimately encounter the same fundamental limitations as their non-thinking counterparts. Okay, so here are a lot of very bold claims that they're making here. The three regimes are fine. I expected them to classify. But one thing that does kind of give this away is that they say the most interesting regime is the third regime. This does bias the results. It shows that these authors are particularly biased in showing that these results kind of suck, you know? We knew that they were biased from the start, but this is, something to keep in mind. There is bias here. Again, we're noting here that basically in these situations, there are regimes where the thinking counterpart seems to perform slightly worse than the other counterpart, than its non-thinking counterpart, and there's regimes where it's better and regimes where they both suck. Right. I guess this is fine. Like, again, I have my own issues with the benchmarks, right? So like here, like Tower of Hanoi. So clearly there's something up with the river crossing. I mean, look at this. I mean, clearly there's something wrong here, right? I just looking at this data, I'd be like, yeah, okay, there's something wrong here, right? Definitely something wrong here. Towers of Hanoi, I kind of believe these results, checker junking, blocks world, again, but I would expect them all to, because they're all very similar because they're all very similar, right? I would have expected that they all kind of follow this curve or something like that. Meanwhile, they seem to be following more of like an exponential decay type of thing, which in some sense might make sense. But keep in mind that like the yellow regime only occurs here. So there's basically only in the Towers of Hanoi, at the start of the Towers of Hanoi, is there a situation where the non-thinking counterpart is better? Because this is such a small, like, it's just one data point, right? Like, they need more data points to really, like, prove their claim that there's three separate regimes, right? So one of the big claims of the paper is that there's these three separate regimes, and really those three regimes only exist here and a little bit here. Like, so I don't know. That's a bit of a stretch for me. I don't necessarily agree with that. And very clearly, it looks like something's wrong with this one, so I'd throw that data out completely. But I do believe generally the results are kind of okay. Like, I do believe that there probably are certain tasks for which the LLM without thinking could outperform the LLM with thinking based on how the reasoning happens. Although, I don't know. Fine, we'll keep going. I kind of like this problem. Let's see, though, because there is a hidden thought chain solution checking mechanism, and any proposed solution has to be checked internally. I can't take over the cabbage first because the wolf. Right. So in a sense, I think you're right in that, like, I think that this one might be the best test, which might be why they thought the results were valid here, because it does take so much reasoning and it very quickly gets into that regime where both things would fail. But it still feels really weird that we have such a steep cutoff, right? Should have asked an LLM and proofread it. I think it doesn't matter in this case. Like, I'm not talking too much about that. How are they binning puzzles into high, medium, and low? Just based on, I think the binning isn't so bad here. It's based on like they talked about this before. Each one of these has a different mechanism for which they are tested. Like, for example, the Tower of Hanoi's tests here, I don't necessarily agree with how they're doing it. They're not testing it based on the final solution. They're testing it based on the, like, how correct each intermediate solution was, which again is why they're testing based on reasoning capabilities. So I understand why they're doing this, but it's still a little bit vague, a little bit weird. Claude 3.7 is already outdated. Claude Opus 4 is much better. Okay, to be fair, like, that naming convention sucks. It seems they emerged empirically based on how the thinking, non-thinking models compared. Do they ever show any of the thinking? They will later, I think. Okay. So three regimes of complexity: collapse of the reasoning model, collapse of the reasoning models. Okay. So at some point here is where they start talking about the reasoning. Okay. So we next examine how different specialized reasoning models equipped with thinking tokens respond to increasing problem complexity. Our experiments evaluate 5 state-of-the-art thinking models: O3 Mini, DeepSeek R1. Okay, Figure 6 demonstrates these models' performance in terms of accuracy, top, and thinking token usage, bottom, across various complexity levels. Results show that all reasoning models exhibit a similar pattern with respect to complexity. Accuracy progressively declines as problem complexity increases until reaching complete collapse, zero accuracy. Beyond a model-specific complexity threshold. Analysis of inference thinking token compute also reveals that an intriguing pattern in thinking token allocation learned by these models. Okay, fine, fair enough. We observe that reasoning models initially increase their thinking tokens proportionally with problem complexity. However, upon approaching a critical threshold, which closely corresponds to the accuracy collapse point, models counterintuitively begin to reduce their reasoning effort despite increasing problem difficulty. This phenomenon is pronounced in O3 mini variants and less severe in Claude 3.7 Sonnet model. Notably, despite operating well below their generation length limits with ample inference budget available, these models fail to take advantage of additional inference compute during the thinking phase as problems become more complex. This behavior suggests a fundamental scaling limitation in the thinking capabilities of current reasoning models relative to problem complexity. So this is their bold claim here. Their bold claim is that there are fundamental issues with reasoning because, let's see, let me just read through this. So this is thinking tokens, right? And this is their accuracy, right? So the thinking tokens here seems to all kind of follow this trend. I'm picking out Claude 3.7 Sonnet because that's what they picked out the text, where you have like a high-ish number of thinking tokens up to a certain rate, right? Meanwhile, the accuracy does fall down in each of these, right? So what they're trying to say is basically they hit the token limit, and that causes them to the budget limit. And when they hit that budget limit, then the accuracy falls down until eventually leading to complete collapse, right? That's what they're saying. So I think they're trying to make some claim here about the number of tokens necessary to solve more complex tasks, but I don't think that's exactly what they're doing here. But the big thing that they're claiming here is that based on these, based on these results, there is a fundamental issue with these large reasoning models, right? Which, for the record, we all kind of know there's a fundamental issue with the large reasoning models. We all know this. It's just, they're trying to make that claim based on these results from an experimental setup. And it's always kind of flawed when you try to say there are theoretical limitations from experimental data. You know what I mean? Like, you have to give some sort of theoretical analysis as to why that's the case. But one of my big problems with AI and AI papers is that, like, there isn't as much of a theoretical base to pull from, right? And so you have to go off the experimental or the empirical experimental evidence, which means that your theory is kind of a bit shoddy no matter what you do. So I do understand that they didn't really have a good way to go about this anyway. So I'm kind of giving them a pass here. But yeah, this is a bold claim of the paper that with a certain token budget, these models will not be able to reason about certain problems, right? Claude is arguably the best naming convention. They number the generations, and the model size is a different name: Opus, Sonnet, Haiku. There's also Sonnet 4. Yeah, I don't know. We'll see. I mean, eventually they're going to run out of like poetic forms to name after. Is the accuracy percentage if it's exponential? Why use logic? Is it exponential? 1K, 2K, 5K. 1, 2, 5. What is this? 1 second. It is logarithmic, yeah. When thinking context window or something else, when thinking for too long, the model forgets earlier thinking and starts wandering around. Okay. So what happens inside the thoughts of reasoning models? So this is another big thing that they're doing in the paper. They're trying to kind of reason about the reasoning of these models, right? And this is one of the big reasons I wanted to read the paper, because I just want to see how they're doing it, right? Because historically this has not been historically, this has not been something that people can do. The numbers are going up, but the poetic forms are staying the same. Right. Anyway, I think it's just kind of weird. Like, if you told me like Claude 4.7, I'd be like, okay, that's better than Claude 3. I get that. But like the Sonnet and Opus and Haiku are confusing to me. But again, what do I know? To gain deeper insights into thinking process of reasoning models, we conduct a fine-grained analysis of the reasoning traces. As shown in Figure 1, our setup with puzzle environments allows us to look beyond final answer and obtain more detailed insight into reasoning thoughts produced by these models. We extract and analyze the intermediate solutions explored within the thoughts of a model with the help of puzzle simulators. Our investigation examines the patterns and characteristics of these intermediate solutions, their correctness relative to their sequential position in the reasoning process, and how these patterns evolve with increasing problem complexity. For this analysis, we focus on the reasoning traces generated by Claude 3.7 Sonnet thinking across relative positions within the reasoning trace. Its correctness as validated by our puzzle simulators, and 3, the complexity of the corresponding problem. This allows us to characterize the progression and accuracy of solution development throughout the reasoning process. Also, they did the academic thing. I hate the academic thing. This allows to. That's not a sentence. Characterize the progression of accuracy solution development throughout the reasoning process. Allows us, there's no object in this sentence anymore. They do this thing where they're trying to write in a passive form that's traditional for academic writing. And then in doing so, they remove the object completely from the sentence. And then like, it's hard to reason about now because they don't have an object in the sentence. Just add us, add we, allows, the person, just add some object there. Anyway, it's fine. It's fine. I don't care. It's fine. That's just one of my pet peeves for academic writing. I gave the Ripper-Crossing problem a DeepSeek R1 and thought for an absurd amount of time and got the answer wrong. Passive voice is more like no voice. I can't stand this particular thing. I actually like academic style generally, but this particular thing is annoying to me. Once it reached ASI, no more names are needed. What are we talking about here? The numbers are going up and the putting. Right, so figure 7a demonstrates the relation between position and intermediate solutions within thoughts, their correctness and problem complexity across all puzzle environments. Our analysis from reasoning traces also further validates 3 regimes of complexity discussed above. For simpler problems, reasoning models often find the correct solution early in their thinking, but then continue exploring incorrect solutions. Note that the distribution, again, this is very typical for optimization problems. Like this is very, very typical for optimization problems. So that to me is not weird. Note that the distribution of incorrect solutions, red, is shifted more upwards towards the end of thinking compared to the correct solutions, green. Okay, so basically what they're trying to say is that, I'm going to finish this paragraph and I'm going to come back to this. This phenomenon, referred to as overthinking in the literature, leads to the waste of compute. As problems become moderately more complex, this trend reverses. The models first explore incorrect solutions and mostly later in thought arrive at the correct ones. This time the distribution of incorrect solutions, red, is shifted more downward compared to correct ones, green. Finally, the problems with higher complexity collapse emerges. Meaning that the model fails to generate any correct solutions within the thought. Okay, so basically what you're saying is you have incorrect solutions in red and green, and correct solutions in green. For Towers of Hanoi, as we increase n, we are seeing that in general, with higher n, we see more time spent on correct solutions. This figure is not, this is not what I wanted to see. Oh, we're looking at the distribution under the figure. That's what we're looking at here. And that's the amount of time spent exploring such solutions. And then we basically put a dot down at the middle of some Gaussian fitted. Okay, fine, fair enough. Okay, so position and correctness of intermediate solutions within reasoning traces across 4 puzzles at varying complexity levels. Check indicates correct solution, X indicates incorrect solutions, with distribution density shown by shading. Okay, I got a couple things to say here. One, I actually like this figure in what it's doing in some ways, and I dislike it in what it's doing in other ways. On the one hand, I do like the fact that this paper is actually trying its best with color coordination and stuff. Like, for example, it has low, medium, and high in yellow, blue, and red. Hey, that's nice. That's really nice. I'm glad that you did that. And I do agree that like they're trying their best to present the data in a way that's readable and understandable, and that's fine. I understand what they're trying to do, and I respect that. I just find that these Gaussian distributions as representations of the amount of time spent on correct and incorrect solutions is a bit funny to me, like position in thinking. So basically what they're trying to say is this Gaussian, how does this work? So what they're trying to say is, they're trying to say that the correct solutions came later in the thinking process for more complex thoughts. Because in the more complex chains of thought, they spent more time in incorrect solutions. And for the less complex thoughts, they would, after finding, I see, okay, I think I'm understanding this now. So after finding, let me zoom in here. Oh gosh, Zern will stop. So let me zoom in here to this figure. So essentially what they're saying is the following. They're saying that this is essentially time on this axis. This is time. Okay, I need to do this with a different marker. So this is time, and this is n, right? That's fine. And they're saying that for a small number of n, we find the correct solution, but then later on, if we keep thinking, we find incorrect solutions, right? And so we find the correct solution and incorrect solution. But then as we increase n, we initially find incorrect solutions, but eventually find correct solutions, right? So essentially, it's just a characterization of the overthinking problem. That's fine. That's okay. That's okay. Also, red and green in the same graph. Yeah, maybe not the best, but also like we are long past the stage where like, you know, like we should not be using red and green for correct and incorrect, but that's just where we're at now. You know, so colorblind people just die, I guess. I don't know. Okay. If interested, here is the thought chain DeepSeek R1 gave me for the river crossing problem. I'm interested. Yeah, give me that. Copy link. The LLMs are verbose, so for basic solutions, they babble a lot. Oh gosh, what is this? Oh geez, this is... Oh no. Oh Jesus. I gotta be honest, one thing I don't like about AI is that its output is impossible for me to grok. I don't understand it at all. Anytime, any AI solution, if you give me AI writing, I can't read it. It's awful. Like, sometimes it's fine. But like a lot of times it's just like, it gives it to me in this way that's like, how could you possibly think this is readable? You know, like it'll give me like bullet points, like do this, or it'll do, I don't know, like I can't read it. So now this is like, whoa, this is scary. Okay, so I'm trying to figure out, oh no, you're doing this in the wrong, I can't read this. Okay, so I'm trying to figure out how to get across the stream with my boat. The boat can only hold me, and one other thing. I have a dog, a sheep, and some sheep feed. You expect humans to be able to read this? Like, that's not human readable in any way. Feed that I need to bring over. If I leave them alone, the sheep will eat the feed, and the dog might attack the sheep. What should I do? Oh god, that's not human readable at all. I need an AI to condense this into something that I can actually read. That's also fair. It's not meant to be read by humans. I get that. Worst part is that it ended up with the wrong solution. It leaves the sheep feed, and the sheep is sheep at one point. I mean, it's a chain of reasoning, effective thinking aloud, not an edited output. Right, but I would expect even thinking aloud for me to, like, I understand that. I understand I'm not supposed to read this. I get that. Totally fair that I'm not supposed to get this. But also, like, it's so far from being, like, you would expect something not to be human readable to be more terse, not more verbose. You know what I'm trying to say? Like, I want less information, right? Because, I don't know, like, basically, the way I enjoy reading and writing is to minimize the number of words on the page while still presenting the maximum amount of information. Like, that is what we do as humans. And that's just not what AI does. It always, like, is overly, again, verbose. It uses too many words. And it writes things in a way that's, like, very unnatural for the way in which I would write it. And that's fair. I'm very critical of people's writing and even my own writing. So, you know, I think it's fair enough. But also, like, yeah, I'm ranting. I need to move on. LM often lie in their overthinking steps. Yeah, but I think that's fair because, again, the overthinking steps here are intermediate steps for them, not us. And so if it's an intermediate thinking step for it, maybe a lie there is actually helpful in it going across a logical gap. You know, like, you know, how do you get over local minima issues in optimization? Well, you do, like, for example, the Nelder-Mead method, where, like, okay, if you're stuck in a local minimum, and you're pretty sure you're stuck in a local minimum, just randomize everything. And that randomization of everything is probably the equivalent of a lie in an LLM. So I think, yeah, I think it's okay. I don't know, I relate to this. I ramble incoherently as a narrative form until I figure out what's going on. Yeah, but also you've indicated in the past that you're able to grok like LLM output much easier than I am, for example. And so, like, I'm complaining about something that is only an issue to me and not necessarily an issue to other people. And you also indicated that, like, for example, you don't like academic writing, but I love academic writing. I also love poetry. So, like, you know, I think it's just a difference in opinion that I have to learn to accept, that some people will actually probably be better at understanding LLM output than I am. And that's just how it's going to have to be. And that's fine. Like, you know, there are different skill sets for different, you know, like, there's nothing wrong with one way or the other, you know? Okay. So figure 7b represents a complementary analysis of solution accuracy within several sequential segments, bins, of the number of Tower of Hanoi environments. Okay, it can be observed that for simpler problems, smaller n, solution accuracy tends to decrease or oscillate as thinking progresses. You're telling me there's an oscillation in figure 7b? I don't think that's what they meant. A solution accuracy versus problem position in thinking for Tower of Hanoi. Simple problems, n equals 1 to 3, shows early accuracy declining over time. Overthinking, moderate problems, n equals 4 to 7, shows slight improvement in accuracy with continued reasoning in complex problems, and greater than or equal to 8 exhibit consistently near zero accuracy, indicating complete reasoning failure. Okay, but where's the sinusoidal oscillation here? A solution accuracy tends to decrease or oscillate as thinking progresses. Where is that? What are you trying to say here? Oscillate? This one kind of oscillates, I guess. I guess they were just trying to like allow for this n equals 3 region or something like that. I'm not entirely sure what they're talking about for oscillation here. It seems like a pretty static kind of like... Anyway, let's just keep going. I'm going to just ignore that word. However, this trend changes for more complex problems where solution accuracy increases with thinking progression up to a certain threshold. Beyond this complexity threshold, in the collapse mode, accuracy is 0. Okay. I don't find the chain of thought readable either. I just meant that it makes intuitive sense to me, and that would be rambly. That it would be, yeah, I also understand that it's rambly because, again, this is intermediate output that we're not supposed to be reading. I'm trying to understand it from that perspective. Okay, so, but it also shows that, like, they think radically different than, like, LLMs think radically different than how humans think, right? Like, I mean, maybe humans do think that way, but at least for me, like, I mean... I don't know, like, it's very wordy, you know, like there are no words going on in my head. When I'm thinking about something, there is nothing, there's no words until it's spoken. You know what I mean? Like there's, you know, like the thought is happening as, like, I can't present those thoughts in words. Like that's not easy, you know, like it's a thought, you know, thoughts cannot be represented in words by definition. So like, despite with philosophers, there's some philosophers who think that the definition of thought is something that could be represented in words, but I disagree with that. Anyway, point is, like thinking does not happen like actively in the same way that, you know, it is being depicted there, right? Like it happens very passively, and then like, you know, if you have to present that thought, it comes out in some way, shape, or form, depending on what medium you're presenting in. Like if you're drawing, it will come out as a drawing. If you're speaking, it will come out as words. Like, you know, it depends, right? So like, it's just such a different mindset that I have to wrap my head around. Also, the dog seems like a potential threat to the sheep, the AI. I bet the chain of thought is that only because a human is trying to teach an LM how to think. That could be true. For me, it's hard to think without talking, but yeah, we're different people in some ways. I always think, furthermore, here's a list, finally. LMs use tokens as intermediate compute, I guess. Yeah, this is a lot here. I also, my understanding of tokens, I need to do a better job understanding exactly how these are used in models and stuff like that. Okay, so let's keep going. In this section, we present surprising results considering the limitations of reasoning models in executing exact problem-solving steps, as well as demonstrating different behaviors of the model based on the number of moves. Let me get some water. So the interesting thing here is I think they're really only focusing on Towers of Hanoi and throwing away the other groups. And I think the reason for that is because this curve that they have for the Towers of Hanoi is itself the most consistent with their claim that there are these three like regimes of thought. And so they're trying to double down on that. But it does mean that they're backtracking on a lot of the claims that they could be making in the paper more strongly, which leads me to believe that they don't. It leads me to believe that they should have spent more time evaluating this, and for some reason, probably due to market exposure, I don't know what the reason would be. There's probably some business reason. They published this paper prematurely. Like it sounds like it was published prematurely, even though I know they have more time with this paper than the next paper we're going to look at. It still feels very premature, the results here. Skimming the AI train of thought pace is generally and discarding a lot of garbage. Yeah, I appreciate that you also, who was it that sent that? Oakless, thank you so much for sending that, by the way. I really do appreciate that you went through the effort to do that. As someone who goes 8A and 8B, the Towers of Hanoi environment, even when we provide the algorithm in the prompt so that the model only needs to execute the prescribed steps, performance does not improve, and the observed collapse still occurs at roughly the same point. This is noteworthy because finding and devising a solution should require substantially more computation than merely executing a given algorithm. This further highlights the limitations of reasoning models in verification and in following logical steps to solve a problem, suggesting that further research is needed to understand the symbolic manipulation capabilities of such models. I think this is a fair statement. I don't see anything necessarily wrong with this statement. I see, you know, even if there is an issue with some of the tests that they have, it is pretty clear that the Towers of Hanoi is probably the best test that they can pull this from, and I think that's a very logical statement given the information that they have provided here. Right. That, yeah, all they're saying is we should probably look into this more, right? Moreover, in figure 8C and 8D, we observe a very different behavior from Claude 3.7 Sonnet thinking model. In the Towers of Hanoi environment, the model's first error in the proposed solution often occurs much later, i.e. around move 100 for n equals 10. compared to the river crossing environment, where the model can only produce a valid solution until move 4. Note that this model also achieves near perfect accuracy when solving the Towers of Hanoi with n equals 5, which requires 31 moves. Well, it fails to solve the river crossing puzzle with n equals 3. When n equals 3, which has a solution of 11 moves. This likely suggests that examples of river crossing with n greater than 2 are scarce on the web, meaning language reasoning models may not have frequently encountered or memorized such instances during training. Well, n equals 3 is the default cabbage case, you know, like, so n equals 3 is like the case that you would expect, right? I would probably imagine n equals 5 or above, there are going to be some issues, but n equals 3 is quite low. Like, n equals 3 is like the solution is on Wikipedia. So there shouldn't be an issue with n equals 3, like, just for the record. This likely suggests that, n equals 3, I guess, is actually, if it starts counting at 0, this is only 1 plus what they had before. So maybe n equals 2 means cabbage, and I need to see what they mean by n equals 3 and n equals 2, but I think n equals 3 is the one on Wikipedia, so I don't think this one should have an issue. This likely suggests that examples of river crossing, but like I think Oakless said this before in chat, like specifically this one requires advanced reasoning, therefore it is a really good test for this. This likely suggests that examples of river crossing with n greater than 2 is scarce on the web. The fact that this statement was made is really leaving me very shaky towards what these large language reasoning models are actually doing. Like, does it have to pull from an existing solution for this particular case? I thought the whole point was that it's reasoning about intermediate output, which should allow for it to not necessarily go on the web for this type of thing. This is a statement where I'm like, is this actually relevant for this text? It's fine. It doesn't matter too much. Okay, so we're at the conclusion. We learned a lot. So in this paper, we systematically examined frontier large reasoning models through the lens of problem complexity using controllable puzzle environments. Our findings reveal fundamental limitations in current models, despite sophisticated self-reflection mechanisms. These models fail to develop generalizable reasoning capabilities beyond certain complexity thresholds. We identified 3 distinct reasoning regimes. Standard LLM outperforms large reasoning models at low complexity. Large reasoning models excel at moderate complexity, and both collapse at high complexity. Particularly concerning is the counterintuitive reduction in reasoning effort as problems approach critical complexity, suggesting an inherent compute scaling limit in large reasoning models. Our detailed analysis of reasoning traces further expose complexity-dependent reasoning patterns from inefficient overthinking on simpler problems to complete failure on complex ones. These insights challenge prevailing assumptions about large reasoning model capabilities and suggest that current approaches may be encountering fundamental barriers to generalizable reasoning. Finally, we presented some surprising results on large reasoning models that lead to several open questions for future work. Most notably, we observed their limitations in performing exact computation. For example, when we provided the solution algorithm for the Towers of Hanoi to the models, their performance on this puzzle did not improve. Moreover, investigating the first failure move of the models revealed surprising behaviors. For instance, they could perform up to 100 correct moves in the Tower of Hanoi, but fail to provide more than 5 correct moves in the river crossing puzzle. We believe our results can pave the way for more future investigation into reasoning capabilities of the system. So, okay, long story short, let's talk about where we're at, right? Fundamental is such a word. Fundamental is one of those words that I don't think they can make a claim that this is a fundamental issue with large language reasoning models, because again, that requires some theoretical approach, and this was not a theoretical examination. It was an experimental validation. I don't know what you could call this, but this is definitely an experimental paper trying to claim theoretical results. That's not okay, right? First of all, we can openly state that's not okay. There's also some open questions we had, even while reading this, as to their methodology. Like, for example, this looks wrong, right? It does look wrong. Thinking about it some more, maybe I was overly analytic. I was thinking about this too much. It looks wrong, but that doesn't necessarily mean it is wrong. It just gives me vibes that we probably should look into this more, right? Ultimately, this paper, if I had to summarize it in a few sentences, is their heart's in the right place in that, like, we do need more thoughts revolving around using and reasoning about large reasoning models. That's true. However, this particular paper looks like it needed a little bit more time in the oven. Now, the question is, did it have enough time in the oven to actually, bake a good cake? Like, does this actually, present a point effectively? And I would say, overall, vaguely, yes, it does. At least for me, I'm relatively okay in buying a lot of the results. especially after Oculus in chat like showed me what the intermediate reasoning steps look like for, I don't remember which one, but after showing me these results, I'm kind of like, okay, it's okay. I don't mind. One of the authors is only a second-year PhD student. That's okay. I don't mind that too much. Second-year PhD student is better than undergraduate researcher. I'm actually totally fine with that, and it makes sense that they're first authors. So second author PhD student gives me a lot of actual like more. I feel more confident in the results now, knowing that they're doing their PhD, and it's probably related to this. Okay, right. So other things. The 4 puzzles were mathematically similar. I feel like that's the case. And in this case, I feel like we want more tests with more breadth, right? So, and for the record, though I came into this paper thinking that they would provide a better testing framework, something like the Die-Hard tests for large reasoning models, that's not what they're providing, and they did not claim to provide that. They just were giving a set of tests that were similar that show reasoning failures. And specifically, they chose these tests so that they could look into the intermediate steps and have more of an understanding of really detailing this overthinking problem. So ultimately, this is some good research for a PhD student, or really anybody. It's some good research. Like there's reasons why this was published, and I get that. I'm a little bit upset at some of the claims, but I'm not too upset at the overall results from the paper. I would generally buy most of them, with some limitations that we talked about. Large language models lack any spatial awareness, though is consistent with chess games I've seen ChatGPT play. Wouldn't a more linguistical problem be better at evaluating reasoning? And yeah, right. This is exactly what I mean. They need kind of a better, they need some better tests. That's definitely true. But I think as a first approach to new methods in, if this becomes part of a larger test bed of algorithms similar to like the Die-Hard tests, like if it becomes part of a larger battery of tests used with these large language and large reasoning models, I don't mind this so much as a distinct result. I think it's fine. It even generated part of the correct solution. Did it say that? It seems to have near a lack of spatial awareness. On further examination, the AI pace keeps ping-ponging back and forth between bring the sheep, then the wolf, and then bring the sheep, then the feed, before getting stuck on both. Failing to consider the possibility of bringing anything on the return trip. This is consistent with the paper's assertion that the AI consistently fails with the problem after 4 steps. Right. One of the authors, so I think that the river crossing problem implicitly requires spatial reasoning skills that AI probably do not possess at all. Right. I think the river crossing was actually a really good test here, much better than I thought, and especially because they say it fails at n equals 3, and n equals 3 I think is a totally valid solution you can find online without too much trouble. I don't believe that the results here are necessarily that bad. I'm kind of okay with buying them. So you're looking into it. Is the actual message it gave in its thinking. The solution is wrong because it leaves the sheep with the sheep feed. Okay, good. I appreciate that. I'll take a look in just a second. Copy, and then I'll take a look at YouTube chat as well. Okay, let's go here. Paste. Oh, paste. Nope. Paste. Nope. Copy. Paste. Why can't I copy and paste this bad boy? Copy link. Paste. There we go. Right, paper is so-so, I think is where I would say. What do we have here? My favorite VTubers live. Bye for now. See ya, Hanif. Thanks so much for being here. I think pure token space work makes them token efficient. I think if LLMs think, right, as intermediate compute, yeah, right. Ideally, we should not force LLMs to think in human language, but it's needed for evaluation, right? So this is exactly where I'm kind of like a bit confused at these intermediate steps. Like, first of all, the intermediate steps don't feel like human language to begin with. That's number one. But two, like, really the fact that they're expressed at all in human language is super bizarre to me. Like, I need to like wrap my head around that one. Because again, human thought doesn't happen in human language. So why would LLM thought happen in human language? Like, why are we restricting ourselves to an inefficient format? What if 4 puzzles were mathematically similar? The solution is a list of moves that might have a similar shape for the 4 example, just in case. I like the paper reading session though. Yeah. No, I really do appreciate you guys being here and reading the paper together. Is there a link to this paper? I'm curious to know what they mean by N in the river crossing puzzle. Yeah, so let's just go here. See, this is the thing though. Like, when I said humans don't think in a human language, I don't think in a human language. Like, my thoughts don't happen. Like, I don't think in English, the thoughts are not in English, but I know some people do, right? So I wasn't saying all humans don't think, I meant like a specific subset don't. And I know because I'm a counterexample who does not think in a human language, right? So my brain doesn't think in English, or any language, right? It just, the thoughts happen and then they just express themselves as they want to express themselves, whether that's in whatever format, you know? Anyway, long story short, what I was trying to say is that like, it's not, yeah, sorry, let me give you guys some links as well. So what I want to do is illusion of thinking. I think I just go to Scholar. I'll give you guys both the links. I should have given you guys the links earlier. Thinking through illusion, the illusion of thinking. So this guy, copy link, paste it here. Okay, why is my copy link not working? Copy link address, maybe? Paste? No? Okay. Let's just grab this bad boy. Click there, yank, yank, paste here. There you go, that's one. And then the other one, which we're going to get into now, is the illusion of thinking, which I'm going to do here, I guess. I just have to go to the PDF, I guess. Copy link. Is this gonna work? No, that doesn't work. All right, let's go here. No, okay. I don't know how to give you this PDF, but I know I can find it if I look it up on the archive. It's on YouTube. I can just give you the link on YouTube. Why is it? Whatever. Here you go. Here's the other one. Bam. No, stop. What is going on with my... I can't give you guys links anymore. What's going on? There you go. Okay, those are the two papers. I think the AI thinks the solution works because, well, the sheep won't eat too much of the feed if I'm quick. And the whole point of having a sheep feed is so the sheep eats it. So it's fine if it eats it. What the heck? How is it possible to not think in your language? How are you able to have an internal conversation? Okay. So here's the thing. I'm going to have to explain this because I have to explain this to everybody. Let me just open up Zernal PP, and we're going to have a brief side tangent before going into the next paper, which should be short. We've already been streaming for 2.5 hours, so I don't want to extend the stream for too long. I've made the following claim. Humans don't think. And in language, right? That's what I made the claim. The claim should have been, I don't think. I don't think in language. And I am human, right? That's what the claim should have been, right? That's what it should have been, right? So the reason I made this claim is because it is a particular way in which I think, right? In which words do not exist until they're spoken, right? They just don't exist until they're written down on page, until like, even when I'm reading the words, like I don't hear a voice in my head or anything like that. So what I've learned over time is that other people actually genuinely do hear voices in their head. Like when they're reasoning about something, they will hear words. Words will appear in their brain, right? Or in some fashion. I don't know what that fashion is, but like there will be like a voice in their head, like reasoning and talking to them type of thing. But that does not happen for me. It just doesn't. Like I can't explain it to you. It just doesn't happen. Like the words don't exist until they come out of my mouth, or I write them, or I draw it into existence. Like again, thoughts can exist. It can exist as drawings or pictures or any other thing. But like it's more of like a vibe. Like I know thinking is happening, right? Clearly thinking is happening. I'm an intelligent person. I would like to think, but I can't present that thought until the moment in which I'm measuring that thought at the last moment, right? I don't know why this is the case, but I think it's like 25% of people don't have an internal voice or something like that. I think it's called the internal voice. Let's see, but a lot of people don't. I think. Let's see. Do people actually hear the internal monologue? There's something about this. I don't think it's aphantasia, but there's groups of people who just don't have an internal monologue, and I don't. So that's just how it is. You know, I'm sorry to say. Imagine Apple. Imagine you using telekinesis to throw the apple at me because I'm a stupid nerd. What language is that thought in? Well, obviously there's no. Yeah, for me, there's obviously no language. Maybe other people have that. Can you think in a language at all? I can do both. I can force myself to conjure up words, but ultimately, no, I can't. It's very, very difficult for me to, it's very hard for me to reason about something in any language at all, right? It's hard, very difficult. In my opinion, a thought doesn't have to be in any language at all, right? I don't think it has to either, obviously. Also, stop throwing apples. Babies also think even if they don't know language, right? Thinking precedes language as a child learns. I think, so in my opinion, like I actually wrote an entire book. I wrote an entire book about this process, right? It was a science fiction book about a world where all barriers were broken down. And that includes a language barrier, right? And I saw no problem with this because I don't think in a language. So I had to present thoughts as they were actually thought in my head, right? And so I created this arena where people would experience ideas together, but even that wasn't right. I spent years on this concept trying to figure out how to distinctly present what a thought is to somebody. And then finally I figured it out. I was like, this is probably the easiest way for me to present a thought, to present it as a memory of someone going through the experience, and physically representing tokens and stuff like this. It was a very abstract idea, right? And I remember I distinctly was talking about this concept to one of my friends, and he looked at me like I was insane, because he's like, why don't you just write the words down? I was like, but there are no words to express thought. Thoughts are not expressed in words. That's just a metaphor used in writing, right? And we had this huge discussion back and forth about what this meant. And fundamentally, we came off that without understanding either of us. And then later I realized that actually, when people are writing like thoughts in books, like I thought this, like, some people genuinely do think that way. Like, that is how some thoughts actually happen, right? It doesn't happen for me, but like it took me a very long time to recognize that that's actually a valid way of thought, like just because it's so radically different than how it works for me. So long story short, that was the reason I'm so surprised that internal monologues happen for AI as well, because it's so foreign to the way in which I think, and I recognize myself as a human at least. And so that's kind of where I'm at. Okay, so let's keep moving on to the next paper, because I don't want to ramble about this too much longer. How do you conclude a final thought? I have aphantasia though. I'm guessing if you need to store something outside of your short-term memory, you just use language. At the very least, I rubber ducky internally occasionally, most of the same situation. I might use an external one. Do you do that? So what I'll do is, like, if I have to present a thought, like, and I know I'm going to present something to you guys in particular, I will sometimes rehearse it beforehand, like before stream or something like this, because otherwise I can't hear it. And so like, I don't know what the thought is. I mean, I know what the thought is, but I don't know how it will sound until like I verbally speak it out. Yeah, so I have to do it that way. It's an internal feedback loop. So how do you know what the previous thought was? Oh, thoughts aren't like, they're not objects, like it's not like you go, like, let's say I can't really explain the reasoning, but like, it's not like this is happening exactly, right? You have point A and you have point, let's say B, C, D, E, F over here, right? Like very clearly there are logical steps to go from here to there, and here from there and here to there, but I don't know that. Like, I'll just state A and F, and then I have to backtrack to figure out how I got there if someone asks me my reasoning, right? Like, I'll be like, oh, very clearly this comes from A, without any question. Like, that is how it works. And then when people ask me how that happened, it's like, oh, well, I guess, I suppose this goes to this and to this to this, and then I have to state those facts counterintuitively, right? Because the connection between A and F happens innately. It happens like, like that. You don't have to think about that, like, well, you are inherently thinking about it, but like that connection happens immediately. And then the question is, how do you backtrack in order to prove that A is F? Like, that's the question that you have to prove to other people, right? And so like, immediately, intuition happens. And intuition is A and F are connected, right? That's the intuition. I know these two are connected, and I know they're connected. But now the question is, how do I prove that connection, right? And that proof of that connection is what you do. So really, for me, this connection, the intuition happens, and then the backtracking happens. Not like A leads to B to C to E, F. I don't do it that way. It's not like, well, if this is true, then this is true. And if this is true, then this is true. It's more like, oh, intuitively they must be connected. And then after that intuition happens, you then go back and goes there. Maybe I should start, let's see. I know what a rubber ducky is. I thought I was using it correctly. AIs aren't internal monologuing though. It's just more text prediction that's hidden from the user. That's probably fair. Like in that case, I'm more okay with it. I'm in the opposite of artificial intelligence. I'm genuinely stupid. Maybe I should have started with, are you familiar with rubber ducky? A friend of mine thinks in colors and sounds. Every letter and every word, a number for him have a specific color. Every word a different sound. A room full of people talking, making noises for him is like 20 orchestras playing wildly. Actually, yeah, I don't think I have synesthesia, but certainly I have weird connections between colors and thoughts, and specifically colors and personalities. I don't know exactly why, but like, people have colors to me, and like I can tell you like this person is white and white is chalky, and I don't really like white, but I can tell you like this person is like blue. I like blue. Blue is generally knowledgeable. Purple is someone that I don't quite understand, but I think is on the right track. Yellow is very trustworthy. It's like this type of thing where like I have somehow I just have colors, and when I see people, I naturally see a color associated with them. It's not like I see the color physically. It's just that when I think about this person, they are that color. So like I'm not saying I have synesthesia, but like I'm saying that like, certainly there is like some weird color thing going on with my brain, and I'm not saying I don't think what I'm doing is neurally typical, if that makes sense, but I don't know if it's neural atypical because I haven't really asked anyone about it. I wonder if it could be considered a valid layer of abstraction. A majority of thought is subconscious, black box of our own. Right. That's how I feel as well. Since there's no actual intelligence, it's text precision sounds like a form of synesthesia. Synesthesia. This person is white. Well, I see auras. I'm green. Well, you are green. Well, yeah. Okay, never mind. When you read a sentence not out loud, do you hear the words? No, I don't hear the words. I'm blue. What a reference. Okay. Sometimes before a crash, you get a feeling that something, some sort of non-verbalized thought, right? So I said this earlier in terms of how I read, and the reason I have trouble with dyslexic thoughts, the way in which I read is I basically have I just read the first 3 characters and then look at the rest of the word. And so I don't actually read words in full. I can't read words in full. It's very hard for me to read. Reading aloud is something I was not able to do until I started streaming. I was literally 25, 26, and I realized, oh, I have to read aloud on stream. That I started getting the ability to do so. I was fundamentally unable to do so for the longest period of my life, which was fine for the most part. It meant that what I'd have to do is I'd have to, whenever I had to read something for class, I'd have to read it first, internally memorize the entire thing, and then I'd have to regurgitate it out and hope that I didn't miss anything. That's it. I just hope I didn't mess up. I worked most of the time. I don't know. But yeah, reading aloud is very difficult for me because it's basically skipping my brain entirely. Long story short, I understand that people think differently. And, this is also true for everything. Everyone has different thoughts. By the way, I missed a couple follows. Late Steve, thank you for following. I think I said thanks for following earlier, Kuno. Thank you, guys. I think he said as a form... I have a form of autism? Maybe. I don't know. A lot of people think I'm autistic. I don't know if I necessarily buy that. Okay, we have one more paper to go through. This paper is not necessary. It's not very long. But after reading the first paper, we have a couple things to keep in mind. Let's just re-evaluate where we're at. So we just read a paper from Apple, people who work at Apple, which basically state that, hey, first of all, we don't really have good tooling to evaluate large reasoning models. And second of all, these large reasoning models seem to fail at certain levels, right? And this seems to be a fundamental issue, right? Now, the bold claims is that this is a fundamental issue with large reasoning models in general, and the bold claim is that these tests are sufficient to prove said claim. So those are the 2 claims that we're really testing here. Now, it did particularly make the large reasoning models look kind of bad. It said that, well, they can't be used for these models, for these purposes, when humans probably could reason about this thing. And so now we're looking at a rebuttal. Now keep in mind, this rebuttal happened 3 days later. So I could imagine what happened. What happened was people saw the paper from Apple being published, not even published, put out in the archive. And 3 days later, right? 3 days later, these companies, probably via some AI generated nonsense, output another paper rebutting that response, right? I am interested to hear what they say, but we cannot evaluate this paper as stringently as we evaluated the previous paper. And the reason is it was made in 3 days, and it was very clearly a hasty decision based on some random person in a board somewhere. So again, we cannot think about this too deeply, but it's good to go through the rebuttal and see what they have to say. I'm very interested in a few claims that they're going to make, namely the 3 claims, which are the Tower of Hanoi experiments systematically exceed model output token limits at reported failure points, right? Now, the reason this is important is because if we go back to this paper over here, we note that there are actually a lot of failure points in here, right? It fails pretty hard in these areas. So is the paper claiming that this data point and that data point aren't valid? Or is it claiming that all these data points are not valid? So that's what we're looking at. How many of these data points are they trying to throw out? And the other thing that it says is that the river crossing benchmark include mathematical impossible instances for n greater than 6. But again, here's where it doesn't matter. It doesn't matter that n greater than 6 is broken because they said it fails at n equals 3, right? And so it doesn't so much matter that these are mathematically impossible for n equals 6 because we're already looking at failure at n equals 3, which is totally a valid solution, right? So, are you kidding me? Is this Opus? Oh, screw them. I'm not reading this paper. This is absolute garbage. You're telling me this is an AI generated paper? Give me a second here. They're telling me that this is this actually an AI generated paper? A first author AI generated paper? Oh, I'm not reading this nonsense. First of all, I'll just read the abstract. This is another one without Opus. Let me find the other one without Opus. I'm not reading a paper that's AI generated. I'm sorry. They're trying to make claims here, but first of all, just from the abstract alone, we know that this third point the third point, which I thought was reasonable, is not reasonable based on the previous paper, because who cares about n greater than 6? 1, the Tower of Hanoi experiment systematically exceed model output. Again, This could be valid, but I don't think it's super valid. So really, we're only interested in two, which is the author's automatic evaluation framework fails to distinguish between reasoning failures and practical constraints. That's the only one we really care about, which we had identified earlier. If there's another one without Opus, could you guys give me a link? I'm interested in reading one that does not have Opus in it. I'm not going to read a paper that was written by AI. I'm sorry. I might look at the figures if they have any, which they don't. So screw this. I will look at the results and I'm not going to read the rest of it. I'm sorry. I'm not doing this. But yeah, I was pretty confident that some of this was AI generated. Okay, give me that. Copy link. All right. Grab that bad boy. Grab that bad boy. All right. This is what I wanted. All right. So let me just grab this. All right. Bring it over here. I'm going to delete this bad boy. Discard. I need to open up the right terminal. Yeah. So move that to usuck2.pdf and what? Move. Does that not exist? It looks like it should exist. Oh, that's because I did this wrong. Okay, now we're gonna do zero.pp usuck2.pdf. Let's zoom into this one. Right. So to be honest, the first paper was high on criticism, no doubt, and this one is just a response. Now, keep in mind, I have a couple immediate qualms with this. One immediate qualm is that this is not how research is done. Generally, when people put stuff on the archive, it is to get feedback, and the feedback should be done privately. That's generally how things are done. But because this was a squabble between companies, they wanted to make it more public. Already, I'm kind of pissed off at that. My assumption is that the abstract has not changed too much. And yeah, it doesn't look like the text has been changed that much from the other paper. So I'm willing to just continue from the introduction. Has your attitude on AI changed recently? My attitude on AI is still very much, I do not see a usage for any of these tools, and I probably will never use them in any workflow that I will actively not work with a company if it is using AI. Like, that is it. That's my stance as it is right now. But no, my stance has not changed. I still don't see a utility in the tools, but I acknowledge that some people might, and that's fine. Like, I've always made the acknowledgement that some people might find utility here. But it's like, genuinely speaking, if the company is using AI, it's not doing anything fundamentally interesting. So I should not be using it, or I should not be working with them. This is also my stance on Julia. And like, for example, the scientific machine learning crowd, I'm genuinely against scientific machine learning. And I will not work with anybody who is working on any of those tools because it's a scam. It is a scam. I don't care what people say. Okay. So let's just kind of go through. It is a short retort. Again, that there was the Opus. I don't want to read this if there was any AI generated shit in here. So the only thing I really care about is the claim. So I don't care about the river crossing claim because that's actually not particularly useful here. The authors have compositional depth minimum. Gosh, this really makes me not want to read the paper at all, too. Man, I hate that. Okay, claim to have identified fundamental limitations in large reasoning models through systematic evaluation on planning puzzles. Their central finding that model accuracy collapses to zero beyond certain complexity thresholds has significant implications for AI reasoning research. However, our analysis reveals that these apparent failures stem from experimental design choices rather than inherent model limitations. It's a reason for the stream. He now believes AI is going to save humanity. No. A friend of mine is an AI department in a company, OCR stuff. They try to sell his company so many AI services that are just ChatGPT way too many times. What is OCR in this case? Sorry, I should know. Okay. So let's go through. A critical observation overlooked in the original study. Models actively recognize when they approach output limits. A recent replication by Scaling on Twitter captured model outputs explicitly stating, the pattern continues, but avoid making this too long. I'll stop here. When solving Tower of Hanoi problems. This demonstration demonstrates that models understand the solution pattern, but choose to truncate output. Don't give me a Twitter. What is this? What, are you like 5? Don't give me a Twitter. I don't want a Twitter. Gosh darn it, what the heck? What is this? I mean, I understand it's a response. I should not be too, like, mad at this, but also, like, I am kind of mad at this. Okay, 1 second. How do I even open up this stupid link? Oh, you kidding me, for Pete's sake? Okay, so now I have to go over here, CD projects, papers, 07. All right, now I have to do Firefox, you suck 2.pdf. All right, now I have to go to that link, and I have to look at that specific Twitter, which I don't know if I can do because I don't have a Twitter account. I might have to log in. All right, what do we have here? For n equals 9, n equals 10. Okay, but who cares about n equals 9, n equals 10? Let's take a look and see who cares about n equals 9, n equals 10. All right, so let's go back over here, and let's take a look. N equals 9, n equals 10. So actually, n equals 9 and n equals 10 are actually valid here, because this is within the reasoning limit, right? And so what they're saying is any results past 9 and 10 should not be looked at. Let's see. So they're trying to make the claim that the Towers of Hanoi cases here are not valid. Any of those cases are not valid, is what they're trying to make the claim, which would significantly change the results, specifically for that one test, no doubt. So let's see what they say. Okay. Let's see. Such evaluation limitations can lead to other analytical errors. Consider the following statistical argument. If we grade Towers of Hanoi solutions character by character without allowing for error correction, the probability of perfect execution becomes the following, where P per token. Okay, we did also acknowledge this, that the Tower of Hanoi evaluation is probably not the best. And we also acknowledged that the river crossing one is probably the best for higher level thinking and reasoning. Like, that's probably the better one if we're looking at the tests. It's just for some reason they highlighted Towers of Hanoi, and the reason they were highlighting Towers of Hanoi was a bit weird for me. I don't know why. This type of statistical inevitability argument has in fact been put forward in the literature as fundamental limitations of LLM scaling, yet it assumes models cannot recognize and adapt to their own limitations, an assumption contradicted by evidence above. What evidence above? What evidence above? Okay, again, this is a rebuttal. It's fine. It seems like he wants to do original science, social media as a reference, humanity's cooked. I don't mind social media as a reference. That's okay. But like, at least do your own. Like, this is a paper. Like, it's not a paper. I understand it's not a paper. It's just on the archive. That's fine. It's probably not going to be published anywhere. That's fine. But still, like, at least do the thing again. You know what I mean? Like, just show that you could also replicate that. Like, do something. Like, do something. Like, that's all I'm asking. Optical character recognition. Well, I mean, okay. Does that use generative AI at all? Like, I mean, that's a completely different thing, isn't it? This is an angry blog post pretending to be an academic paper. That's exactly what this reads like. The evaluation issues compound dramatically in the river crossing experiments. Test instances of n greater than 6 actors agents using boat capacity b equals 3. However, it is well established result that the puzzle and its variants have no solution for n greater than 5. Okay, see, but who cares? Because again, n equals 3 was when it broke. And n equals 3 is well before n equals 5 in this particular case. I mean, if you look at the results, look, I mean, we're talking about 6 and above here, right? But I mean, like, it doesn't matter because it already failed at 3. All right, let's keep going. By automatically scoring these impossible instances as failures, the authors inadvertently demonstrate the hazards of purely programmatic evaluation. Models receive 0 scores are not for reasoning failures, but for correctly recognized unsolvable problems. Okay. This is a fair statement. Like, again, we have to be more careful about how we're doing the analysis. That's fine. That's fine. Okay, I didn't think about for adversarial stuff. You're right. A previous version of this paper assumed that the evaluation required outputting all intermediate states based on the instruction set in A.1.1 of Shoji et al. That models should include corresponding complete lists of moves during the thinking process. However, multiple commenters have what are we talking about here? Have correctly noted that, what are we talking about? Multiple commenters in an academic paper? What are we doing here? Oh man, that pisses me off. Like, I mean, it's fine to say, but you can't say multiple commenters. That's not a phrase you can use. An academic, what are we, I'm sure it's Twitter commenters. That's fine. But you can't just say, oh, many people are saying this. No, you have to at least validate that claim. Oh my word. Okay. Have correctly noted that in practice, models do not output each intermediate state when reasoning through large. Yeah, I had this issue as well. I understand this claim. The intent of the original instructions seems ambiguous, but we have updated this section to do more closely track model behavior in practice. Following verification with OpenAI's tokenizer, we use 10 tokens per move and calculations as below. If the models output only the final sequence of 2n-1, the token requirements grow linearly. Where C represents the overhead for the problem setup and formatting. This yields maximum solvable sizes. Sure. Okay, that's fine. Interestingly, the reported collapse before n equals 9 for most models occurs well before these theoretical limits. This suggests that models are making a decision to terminate output before actually reaching their context window limits. As noted in section 2, models explicitly state reasons like to avoid making this too long when truncating solutions. So they're harping on the Towers of Hanoi, which is fine. It's good. I actually do respect that they are trying here. Like I do respect that they are, like, again, basically, they saw these results. I think he was like, these results are garbage. I'm sure he thought these results are garbage. And he literally is posting, like, this is an angry Twitter post is what this is. This behavior indicates that models may be poorly calibrated about their own context length capabilities, choosing to stop prematurely. While the specific mechanism differs from our initial analysis, the high-level conclusion remains unchanged. Apparent reasoning failures reflect constraints on solution length rather than fundamental reasoning limitations. Models understand the algorithmic solution as demonstrated by their ability to generate compact recursive implementations, but choose not to enumerate exhaustive move lists, whether due to actual token limits or perceived ones. The distinction further emphasizes the importance of evaluation design. Scoring models as failures for making reasonable engineering decisions about output length mischaracterize their actual capabilities. I don't know if it's a mischaracterization. It is a failure, but you could say that they chose to not do it. Okay, fine. The fact is they still couldn't do it. It's fair, it is a mischaracterization. I will agree with that argument, but I don't think it fundamentally changes the output of the paper in this way. Okay, alternative representations to restore performance. Okay, so prompt, solve Tower of Hanoi with 15 disks. Output the Lua function that prints. So this is completely invalid. I'm not accepting this one because that's not the point of a benchmark. Okay, look. When you do benchmarks in a programming language, the point of the benchmark is to eke out one specific issue that you have with the language itself. Like, for example, if your programming language is bad at recursion, right, what you're going to do is you're going to do some sort of, let's say, Sierpinski triangle solution, right, which deals with a lot of recursion, or could, depending on your implementation, right? Cool. So you'll do some sort of Sierpinski triangle solution, and there's multiple different ways you could do this. You could solve it via the chaos game non-recursive, or you could solve it via an incredibly recursive method, right? But your job as a benchmarker is to figure out where your language fails when it deals specifically with recursion. So saying that there's another alternative approach that would actually enable our system to solve this problem misses the entire point. The entire point was that we're using the logic and the reasoning capabilities of the algorithm presented. And by using that and by testing that, like, we're trying to test that infrastructure. We're not trying to test its coding capabilities. We're trying to test its reasoning infrastructure. So, just giving it another argument, like saying, oh, let's just try a different way, that's not okay. Like, that's definitely not okay. I think anybody that does any type of benchmarking understands that that's not okay, right? That's not okay at all. So I'm already pissed at this paper for the commenters' comment. I'm now doubly pissed at this paper that it doesn't seem to understand the point of the original paper and is misrepresenting the claims. I didn't even like the initial paper, but this is making me love the initial paper Okay, let's keep going. Reevaluating complexity claims. The authors use computational depth, minimum moves, as their complexity metric, but this conflates mechanical execution with problem-solving difficulty. This is a fair point. Towers of Hanoi, despite requiring exponentially many moves, has a trivial O1 decision process per move. Block's world, however, is much harder. This explains why models might exceed 100 plus Hanoi moves while struggling with short. Yeah, I mean, this is a true point. Like, this is exactly what we were saying before. Like, it is good they pointed that out, because that is actually something that they should mention in the paper. That is a very clear criticism of the paper that they should have mentioned, and that is that the complexity of each step is drastically different. So even though, like, algorithmically the solutions are similar, like they're a similar classes of problem, I think one thing that the paper did do is have different computational complexity in each step of the solution of the problem, if that makes sense. So, like, that is one good reason. Like, they didn't have a good breadth of tests to choose from, but the tests did have good depth in them, if that makes sense. And so for that reason, I don't mind the original paper too much, and I'm glad that they pointed this out in the rebuttal. The optimality question, a critical distinction, but I don't know why they printed this. Only paints the other paper better. Anyway, A critical distinction emerges when examining the original evaluation step. While Shujay et al., Shojay, I might be mispronouncing it, check only for solution correctness across all puzzles, their task instructions vary significantly in the computational demands. The block world prompt explicitly requires optimization. Find the minimum sequence of moves to transform the initial state into a goal state. Remember that only the topmost block of each stack can be moved. Okay, that's interesting. I should have read the appendix. Slaney and Thebao demonstrate that near optimal solutions can be found in linear time using domain-specific algorithms. However, finding the truly optimal solution remains NP hard. Models attempting Block's world must solve the harder optimization variant, potentially spending computational resources searching for provably minimal solutions rather than merely valid ones. Again, this is one of those things where like he's trying to say that there are other ways to do this problem that would solve, but the point of the original benchmark was to tackle this specific reasoning thing, and so we don't want to reframe the question. Like the questions were meant in a particular format as to like test the reasoning capabilities, not to like reframe the like. There could be faster ways to implement or do the problem. That's fine, but that wasn't the point of the benchmark, right? Critically, while the solution checker of the authors only verifies correctness, not optimality, we expect models to attempt what they were instructed to do. A model following the prompt faithfully would search for optimal solutions, not knowing what optimal solutions would pass evaluation. Again, but the point was to, it's okay. Again, this is just, basically they're trying to, basically what this is trying to do is it's trying to like discredit the original paper by doing the classic argument that like you're benchmarking incorrectly. But like, I don't know, I'm against that, right? Oh gosh, I hate this so much. Shojay et al. Results demonstrate that models have awareness for their own context limits, that programmatic evaluation can miss both model capabilities and puzzle impossibilities, and that solution length poorly predicts problem difficulty. These are valuable engineering insights, but they do not support claims about fundamental reasoning limitations. Further work should design evaluations that distinguish between reasoning capabilities and output constraints, verify puzzle solvability before evaluating model performance, use complexity metrics, design evaluations that distinguish between reasoning capabilities and output constraints. I hate this paper. It's not a paper, but I hate it. I hate it so much. Design evaluations that distinguish between reasoning capabilities and output constraints. That's a fair point. I understand what they're trying to say, but I also think they're wrong. No, this isn't the one that the reasoning capability. No. This is the one where they're trying to state that reasoning capability and output constraints. Okay, I don't even know what that means. Verify puzzle solvability before evaluating model performance. Again, this doesn't matter in the regimes that we talked about, but fine. Use complexity metrics that reflect computational difficulty, not just solution length. Use complexity metrics that reflect computational. Okay, to be fair, they should do this. This is definitely something they should do. This is something they should do. That's it. This is something they should do. This should be included in the original paper. Consider multiple solution representations. Okay, so here's what they should do. Here's the thing. Number 3, they should do this one. Check. Definitely do this one. No, they shouldn't do that one because that destroys the benchmarks. Verify puzzle solvability before. Yeah, they should have done this. This is true. And providing that distinction would be useful, though it doesn't change the overall results. And design evaluations that distinguish between reasoning capabilities and output constraints. What does this mean? Evaluations that distinguish between reasoning capabilities and output constraints. I think they're trying to say that like there were output constraints due to the number of tokens allowed. I don't think they need a new design. I think they just needed to qualify this claim. So it's kind of meh for this one. I think they just had to do better qualification. The question isn't whether large reasoning models can reason, but whether our evaluation. Fuck you. What is this statement? Fuck you, man. What is this? All right, that line pisses me off. The question isn't, maybe I'm misinterpreting it. The question isn't whether large reasoning models can reason, but whether our evaluation, all right, that actually pisses me off. It's rare that I'll read a paper and get so pissed off. I'm actually using OpenBox, not XFCE. Sorry. Oh my goodness. All right, that one pisses me off. Also, it is written by AI, and it pisses me off even more. I thank Claude Opus for doing the bulk of the writing and deserving most of the credit. We both thank Andreas Kirsch, Chan, Greenblatt, O3 Gemini, all the people who pointed at the parentheses mismatch in our earlier draft. Parentheses mismatch? What are we talking about here? Like, you're acknowledging someone... All the people who pointed out Claude can't get LaTeX quotation marks right to save us save its life to help full comments. Okay, fuck them. Fuck them. Researchers should license AI models that they use so they don't have to deal with token restrictions. I'm really mad. I'm really mad. Let's see. Ali's approach to reading only humans. You can't write good Turing tests, so results are invalid. I just, first of all, I just don't even. Yes, parentheses mismatches are important. I get that. I'm so mad. Oh, am I so mad? I'm so mad. Okay, look, here's the thing. I didn't even like the original paper. I didn't like the original paper. I was like, these are all the flaws with it. But at least I was like, okay, at the very least, it's someone trying. This one isn't even someone trying. It's literally just some person who is like, yo, Opus, tell me why this paper is crap. I'm going to publish that. I'm so mad. I'm so mad on so many levels. First of all, everything... It's not a paper. It's not a paper. It's not going to be published. That's fine. It's not going to be published. There are legitimate claims that this has made that would make the other paper better. Could this have been done in an email? Yes. The only reason this was made publicly was for two reasons. One, it's a weird battle between, I guess, OpenAI, because that's... Between OpenAI, I guess... Alice contributed to the high-level idea, ran the experiments, provided feedback, and noticed the key mistake in the river crossing. Claude Opus contributed enough to deserve, in Alice's view, to be listed as first author, but this violates Archive's policies, and Claude's name has therefore been removed. Now, look, there's actually a couple things here. One, I do appreciate that this person has acknowledged that they did not write this paper. It was written mainly by Claude. That's fine. Also, this paper is hot garbage. It's not a paper. It's hot garbage. Calling it a paper actually does a disservice for the entire industry of academia that has ever existed. Like, it's okay. It's not a paper. It's just a random note on the archive. That's it. It's a random note on the archive. That's it. That's it. That's what this is. It's a random note on the archive, and that's fine. I was expecting this to be more, considering the fact that people are writing, papers on, people are literally writing, they're literally writing news articles about this rebuttal, and they're like, oh, there's a fight going on. There's no fight here. Literally, some person was pissed off at the results, and they very quickly, in 3 days, generated results, and I'm so mad. I'm so mad. I'm so mad. I'm so mad. Okay, this really pisses me off. I'm so mad. I'm so mad. I'm so mad. I've been a regular viewer for a while. I've gotten this mad before. I get this mad at MATLAB. It's interesting to see the biggest companies in the world act like kindergarten kids. It might technically be a paper if you printed it, but it's really certainly not academic. Let's all just remember how fun and relaxing swimming is. Yeah, look, I was having a good time reading the last paper. And in a sense, I'm having a good time reading this paper and making a mockery of it. Like, the fact is, you're telling me the only thing that this person did was the key mistake in the river crossing? And running the experiments, which there were no experiments in this paper? That's all he did? I respect the fact that he's actually openly acknowledging that he did nothing. That's great. I'm glad you did nothing. But the key mistake in river crossing does not change the results, This paper, whatever it is, talked about Twitter comments. Is this what's happening? Have I just been missing this? Is this what's happening to academia as it is? This pisses me off. Okay, look, I'm mad. I'm mad. This is infuriating, considering articles like this will eventually make archive noisy and separate good stuff from AI trash. There's a lot of AI trash on the archive. There's been AI trash on the archive for decades. It's just that this one is like a new level of AI trash. It's literally some person from some company who got mad at some results that some researchers did, right? Results that are mainly valid but have limitations. That he noted one single limitation that would have improved the results from the paper. That would have improved the results from the paper. But doesn't overall change the results. And that's it. That's what this is. Why couldn't he have sent an email out? The reason he didn't send an email out, the reason he didn't just do what every other person on Earth has ever done when it comes to archive papers, is because he specifically wanted a paper to be out to advance the public image of, I guess, Anthropic is where this guy is. Where is this guy's from? Anthropic, right? That's where he's from? I don't remember. I think he's from Anthropic. But regardless, he just wanted his company to look better. And I'm mad. So AI has regularly been in the academic literature, right? It's fine. It's been here time and time again. It's been here for decades, right? Usually when AI comes up, right, it's someone trying to shoehorn AI into a problem that it doesn't fit. Like, for example, they'll be using it for PDE solving or something like this. And it's like very clearly it doesn't work here. But, you know, it's interesting to see the results nonetheless, right? So there's been this type of AI slop where people are using AI for problems that it's not particularly fit in for at least 20 years. Like, I know at least 20 years. And like every time this happens, people are like, oh, AI can now do this. But when you look at the results of the paper, you see AI actually can't do this thing, right? Like it's a fundamentally different, like it doesn't even get close, right? Anyway, long story short, this paper is another level of AI slop, right? I acknowledge that, right? Alex Lawson. Should I know Alex Lawson? Should I know this person? I don't want your AI overview. Don't give me that. Alex Lawson, ATP tour. I don't know who this is. All right. You can't write a good Turing test, so that's the only way I can read that final sentence in the paper. And back, not a chance, I'm telling you. Okay, so let's wrap things up, shall we? We've been streaming for 3 hours and 30 minutes. That's a long time. That's a long time. Let's just kind of wrap things up, okay? Oh gosh, screw! I already said SciML is a scam, and I'm standing by that. I don't care what you say. If people, I have decades of evidence to support the claim that AI's utility in theoretical physics is very limited, right? And every single time it pops up, guess what happens? We realize those limitations and we are very, very unhappy with the results and we go back to the theory. That's how it's been for decades. That's how it's going to be for decades, I'm sure. People trying to shoehorn AI into physical simulations, there are some specific situations where it makes sense, but in general, it's a bad idea. We all know this, right? We have math. Math is used for these purposes. Part of my issues with scientific machine learning is that there's a very small overlap between the two of them, science and machine learning. It's very small overlap. And there is some good research that happens in that overlap, definitely. I'm not denying that. But a lot of the machine learning crowd tends to think that it can be used for everything on the physics side. I can tell you a couple things that AI could definitely be used for on the physics side. For example, in experimental physics, finding a better way to tune, like, I don't know, like laser optimization or something like that in an optics lab, that's something AI could definitely be used for. Experimentalists spend hours of their day tuning these lasers, when ultimately all they're doing is some sort of human level optimization algorithm. If we could just make it so we have an AI, does some sort of computer vision model, sees what knobs need to be turned, you hook those up to some sort of generator, or not some sort of Arduino board or something like that, and you do the AI there, like you can do the optimization for free before people come into lab every morning, and that saves hours a day, right? Like there's plenty of things that you could use machine learning models for that would actually help physicists on a day-to-day. But unfortunately, a lot of the big ticket items like solving Navier-Stokes equations and stuff, which are the things that most people are trying to use machine learning for, it's like if someone asks you to make them a sandwich and you make them like, I don't know, you make them a submarine. It's like, okay, I guess it's kind of interesting you made a submarine instead of a sandwich, but there's no definition where a submarine is a sandwich. You know, like you've given them something completely different than what they're looking for, you know? And you're claiming that this is a sandwich, actually. I mean, like it's covered by water. You got the submarine covered by water, you know? I mean, I guess, but like, you know what I'm trying to say? Like you're giving them a wrong solution. You're giving them something different than what they're looking for. And you're claiming that it is what they're looking for. And some people buy into it. Some people don't. I don't know, like, I just have years of evidence to support the claim that AI has limited utility in science. Like, I have years of evidence to support this claim, of paper after paper after paper, and I don't have that evidence. Like, so, anyway. Right, let's go ahead and read here. I mean, machine learning is basically statistics on steroids. Scientific fields already have statistics extensively, so why not just a model approximator? Yeah, so this is true, right? Like, there is utility here, no doubt. Like, for example, you can use computer vision models to, like, you know, go through an insane amount of data. Like, there is utility for data analysis and stuff like that. No doubt there's utility here. And it saves scientists hundreds of hours, I'm sure, in the fact that you can sort through this data much, much faster, right? It's just, I'm talking about specifically, like, the big ticket items, you know, like, for example, we are currently using AI to kind of do hyper resolution, super resolution on the James Webb Telescope, right? I think that's the most modern telescope, so that we are like improving the results from this telescope. However, recent results have shown that basically all the AI generated crap that is used for this super resolution is mostly wrong. Like, we have reason to believe it's wrong, right? As you would expect, because it's just guessing as to what's there. It's no different than me, like, guessing as to what's there based on one blob looking like this. You know, like, it's the same thing as me drawing something, right? It's just that AI draws everything at one time, you know, so it looks impressive, but in actuality, it's really only useful for PR because we can't rely on those results. And that's just, it's fundamentally different than solving a PDE. Solving a PDE, right, like, via like any like finite element methods, finite difference time domain. Like, sure, there are limitations to these approaches, but we know those limitations, and we've known those limitations for a while, and we know how to overcome them. Having a big black box guess as to what the solution is, I mean, this is a completely different order of magnitude situation, right? Let's see. I thought GenAI definitely. Let's see. Though GenAI is definitely not very useful for science. Okay, apparently the response paper was intended. That's how I'm reading it as well. You can't beat diffraction limit no matter how good the AI is. Right, that's exactly what I believe as well. What about symbolic regression stuff? Okay, I will give you that there is actually a lot of really useful stuff coming out from symbolic logic and in its relationship to AI for scientific stuff. And so, for example, the problem here is that I'm conflating a lot of ideas when I say AI. Right, I'm conflating a lot. Generative AI has no real place in most physics labs. Computer vision models can have some places. PDE solves via like some sort of deep neural network probably doesn't have a place. What I'm trying to say is like there are places where AI does fit and places where it doesn't. And a lot of times the people who are so pro AI are trying to fit AI into places we know it doesn't fit from historical evidence, right? We know it doesn't fit here. So, you know, like you can keep trying and you can keep making these big papers, but like we know it doesn't fit. Like we already know. So why are we going down these avenues? Why don't we instead use AI where we know it, or where it could be useful in the future, right? Interesting. While he wrote the paper as a joke, but then it was cited as serious work by a lot of people who never read it. What is this? Copy link. Maybe interesting parallel to the history of finite element methods. Engineers used this long before the theory was set up. Right. Okay. When your joke paper goes viral. A few days ago, I called through a paper with C Opus. Yeah. I think this is the exact paper. I think I got caught by this. I definitely got caught by this. First, everything seemed fine. The people who saw my original tweet seemed to think it was funny. They understood the context, and I listed Claude as an author, and that I'm not a researcher. This is basically just a thing I'd done a bit of spare time. I was excited about what would happen when it appeared on the archive, which felt like it would add to the joke. Once it was up, though, the bigger accounts started picking it up. A YouTube channel covered it, calling me a researcher, though luckily only referenced the legitimate errors I found. Twitter account, yeah, look. Look, I should have been more careful. The original version I uploaded had some genuinely terrible sections, stuff Claude had written that I hadn't bothered to detect properly. I'd vibe coded the whole thing and quite frequently asked for an entire rewrite if I wanted a small section to be different. There was a computational complexity analysis that was just complete nonsense. Yeah, exactly. Thank you for acknowledging this. Okay, thank you so much. Who posted this? Thank you, Noctua. I was so mad, and now, like, at the very least, he's acknowledging that, like, okay, this is a joke that went too far. That's fine. Right. Okay, thank you. This helps me this helps me immensely. Let me tell you how much this is. This. Oh my goodness, I was so mad. I understand this is like an April Fool's Day joke that went awry. I get it. Okay, fine. I got caught. Whoa, here's Funny James getting mad at someone's paper. It's just, I didn't get this paper like by browsing the archive. Usually I get my papers by browsing the archive. I got this one because my wife sent me the message. Like, she sent me a message saying like, oh, there's apparently a contentious debate among, OpenAI and Anthropic versus Apple, you know? I was like, oh, okay, I guess I'll look into this, you know? And like, I didn't, this is me not checking the sources well enough. I got a little bit of egg on my face. Yeah. I know I got egg on my face. Pro AI preacher barely knows the fundamental of AI machine learning. Are you talking about Alex, or who are you talking about? Sounds like she also didn't read it. Oh wait, am I wrong about this? I thought, is Alex a girl or guy? I just assumed it was a guy, and that might also be. I had assumed it was a guy, but I don't know. Maybe I shouldn't have made that assumption. Just with a name like Alex, I just assumed guy. Okay, good. Thank you, Justin. Sorry. I'm getting real. Okay. So, Losing control. This was my first time having something I'd made seen by millions of people, and the feeling of it jumping context from joke amongst friends to new archive paper was unsettling. People were pointing to it as a source of authority without having read it, sometimes apparently without noticing the author list. The thing is, I didn't know Opus. You know, I didn't know that Opus, like Claude Opus, I did not notice that. Like, if it would have said Claude, as if with the whole first name, I would have recognized it, but I just didn't. I didn't recognize it until it was too late. Just because I didn't know Opus was even a Claude thing until this stream. So fair enough. Like, good. You catch people like me who are complete idiots. I get that. It sounds like she also... No, she didn't... Well, you're right that she didn't read it. You're right that she didn't read it. But, I mean, to be fair, if there's any of us who's going to get into a computer science paper, it's not her, it's me. And also, to be fair, at the start of stream, we did say this is probably AI generated. I just didn't exactly pinpoint why, but we knew it was AI generated, considering it came out 3 days later. So, if anything, oh my goodness, if anything, yes, I'm angry. I'm still angry, because it's kind of defacing a lot of science. But, okay, that's fine. They did not realize how bad this joke was. That's okay. They acknowledged that. That's fine. Okay, but what this has shown me is that Claude can't write a scientific paper. At the very least, it can't write a scientific paper. Like, we're not there yet. You know, at the very least, we're not there yet, you know? Fine. Yeah. All right, well, let's go ahead and wrap up for today, guys. Let's see. What do we have here? So we have basically read through 2 papers. So let's go ahead and put down our conclusions here. Let's put down our conclusions. All right. Well, hey, better than the news, I'm going to beat this Doom map. Better news, I'm going to beat this Doom map. So, okay, conclusions as to what we did. First of all, today we read 2 papers, okay? One was The Illusion of Thinking, Understanding the Strengths and Limitations of Reasoning Models via the Lens of Problem Complexity. The other which was The Illusion of Thinking, written by A. Lawson and another author who, if you've only watched the introduction and the conclusion, I'm not going to spoil, but we'll talk about in just a second. So, long story short, this paper basically proposed a bunch of different things. It said, hey, let's try to create a new reasoning framework that allows for us to reason about large reasoning models, right? Makes sense. They proposed a bunch of different ideas in order to do this, and in particular for specific problems. These problems were the Towers of Hanoi, checkers jumping, river crossing, and blocks world, okay? I'm not going to go into the details of what these were exactly, but keep in mind these are 3 different puzzles that we kind of know and you can kind of think about from on the internet. River crossing in particular was a little bit contentious, but it's also known as like the goat, lettuce, and wolf example, and if you Google that, you'll figure out exactly what that was. Okay, they had a lot of results. Some of which were good, some of which were not so good. We started dissecting a lot of these issues, and their overall theme here was that there were kind of 3 regimes, where 1, where large language models were actually better than large reasoning models, 2, where large reasoning models were better than large language models, and 3, where there was a fundamental collapse of everything. I would say this paper overall was a bit meh. It was okay. They did, I say, sufficiently justify their beliefs, but there were a lot of questions that came up as to why they exactly did this particular thing. Like, for example, in the Towers of Hanoi, they are specifically only testing intermediate steps, which is a bit weird. Like, why didn't they test with the final results and stuff? River crossing, we noted, is going to be very difficult to scale, and in fact, that is another issue that we'll talk about in a bit later. And just a bunch of weird things about the tests. Like, for example, down here, when they're talking about the collapse of reasoning models, and like what happens during the thought process, they're very much highlighting only the Towers of Hanoi, which is not necessarily the best test to be using. Like, in terms of actual intermediate reasoning, we kind of identified the river crossing as something that requires more reasoning, but because of the way in which the AI just kind of fundamentally failed in their tests of here, they decided to go with the Towers of Hanoi, which has a much cleaner curve. Cool, fair enough. So kind of minor nitpicks from me. Now the second paper. I'm going to talk about the claims in the second paper, and then we'll talk about the overall, like, what the second paper was in context that I only learned after the fact, which puts a little bit of egg on my face, but let's keep going from there. So this paper was written, and it makes a bunch of claims, and I'll go ahead and read them out. One is that the Tower of Hanoi experiments risk exceeding model output token limits, with models explicitly acknowledging these constraints in their outputs. 2, the author's automated evaluation framework fails to distinguish between reasoning failures and practical constraints, leading to classification of model capabilities. And 3, most concerningly, the river crossing benchmark includes mathematically impossible instances. So, their claim is that the Tower of Hanoi is not necessarily a really good experiment. 2, that they failed as authors. And 3, that the river crossing is actually not particularly valid, right? Now, All of these are, 1 and 3 are minor nitpicks to the paper, which really should have been communicated via email, not via an archive paper. That is just kind of bad practice on the author's part, but we'll get into that in just a second. 2 is an incredibly bold claim saying that the entire paper is invalid, basically due to the nitpicks that are 1 and 3. So what are the nitpicks? 1, the Towers of Hanoi problem. Basically, just fundamentally doesn't work because the number of tokens that were being used to do that process led to more failures. Basically, when we get to this region and beyond, right? Where in principle, those failures would not have happened with more tokens, right? So basically what they're trying to argue is that, like, fundamentally, this test was a failure or does not necessarily show the failures as they were supposed to, right? Essentially, the model itself gives up here instead of it fundamentally failing here, right? And there should have been a distinction between those two. And I do agree that the original paper should have made that distinction, so that's fine. Number 2, they say that the river crossing is actually mathematically impossible to solve at n greater than 6. That's fine, and that's actually incredibly valid. Unfortunately, n greater than 6 is already past the failure point, so it doesn't actually change the results of the paper at all. And point number 2 was actually not elaborated at all in the paper, and to any extent. Now, while reading this paper, I started getting very frustrated. Let me explain. First of all, the paper was published only a few days after the original paper was published, right? And again, these aren't published, they're on the archive, which means they're not going to be published. And so I acknowledged while reading this paper that this second paper is almost certainly not going to be published. There's no situation where this paper is going to be published, but it is still in the archive. And in principle, archive papers have some level of notoriety to them. Like, it means that something happened noteworthy, at least the author thought something noteworthy happened, and therefore they are publishing for this reason. Now, so let's go down and let's talk a little bit about this. I got really pissed off at a lot of this paper, namely things like how they wanted the original authors of the paper to reframe the question that they were asking in terms of, like, asking them to generate code to do X instead of actually doing X itself. Because again, this is the classic benchmarking problem. If you're going to benchmark a language at its, difficulties in doing recursion, and to do that, you're solving a chaos game or something like that via an iterative function system to generate a Sierpinski triangle, or something like this, well, you're not going to reframe the problem such that it avoids recursion. Your point is to figure out how recursion works, and you chose that particular test and wrote it in a particular way to show recursion. And so asking the model to reframe itself in a way that it can better analyze the results to better get to the results is, it's not the main point, right? Obviously, that is not something that the main author should do. There are a bunch of other things that were mentioned here, and I just kind of said that they aren't really good suggestions for various reasons. Now, here's where things started going out of hand. I overall acknowledged that this paper was kind of crap. And even before reading this paper, I acknowledged that it was probably written by Claude Opus, because the other author that was here before, if you watched the introduction, was C. Opus. I just didn't notice that until recently, right? I was willing to forgive that, assuming that the main author actually did most of the writing, but they openly acknowledged that Claude did most of the writing here, which is, in a sense, good news. It means that Claude actually can't write papers anymore, is not very good at writing papers at the very least. So, academics are safe for a little bit longer. But yeah, as we went through, it just became more and more clear that this was definitely not a paper in any traditional sense. It talks about Twitter, it talks about Twitter commenters, it does a whole bunch of things that you just shouldn't do in a paper. And though it does have some original criticism, ultimately that criticism should have been sent in an email, not as a separate archive paper, which is very threatening for academics, right? Now, after this was done, someone found this particular blog post, okay? Someone posted this blog post, and it put everything into perspective, right? Put this into perspective. When Your Joke paper goes viral, by the author of this paper. Cool. So, long story short, this person does go through and explains that actually, to be honest, this wasn't intended to be a serious thing. It was intended to be a kind of minor, if anything, a minor nitpick of the original paper, and just kind of a joke saying that, oh, look, AI is generating a paper. I don't really know where the humor is in this joke, because for me, it's not funny at all. But I do recognize that people have different senses of humor, and I guess this is a joke to them. And that's fine. If the entire industry of academia is a joke for someone, okay, I really don't like that person, but I understand, they did not mean necessarily harm by this. Was harm done? I would say yes, harm was done, because a lot of people picked up the rebuttal to this paper and started, circulating it around different areas. In fact, this paper was given to me by my wife, who found it via an article that was talking about limitations in AI, right? Which indicates that at the very least, that article was going through and taking the claims of this paper seriously, right? And so it's one of those things where, really and truly, that paper should not be on the archive anymore, and it should not be findable. Like they should be taking it down. And if I was Alex, I would take it down if it was meant as a joke. I think the reason they're keeping it back up is simply because there were some valid claims about the original paper, which is true. There were some valid claims, as I mentioned before. So long story short, I got very frustrated while reading the second paper. I usually do not get frustrated with papers, but this one in particular frustrated me. I think, again, I just don't, there are a whole bunch of different reasons for it. And that's kind of my overall overview here. I don't really have much more to say, just that the original paper, though it has its flaws, I think is kind of okay. The rebuttal is a complete slop. Like, it is just complete slop. There's like one good point there, but the rest of it is complete slop. And really, you shouldn't read it. So those are my suggestions. When you said ideally company, so I'm going to read chat now. When you said ideally companies should only train with data they gain with consent, why is it different from anyone reading a book and learning from it, or me watching your stream and changing my mind? I only see it as something bad if I'm outputting third-party content verbatim. Otherwise, it's a very slippery slope. Humans can learn from all data, but machines can't. I don't think we're here during the stream, and you only came in at the last minute, and you're asking me to respond to something that I made with regards to a video I put out on AI a while ago. I assume that's what you did. I'll get to that comment later. Thanks for sharing your approach on reading papers and the commentary. I beat the Doom map. It was pretty big. Proof by Twitter. So it was intended as a joke, but turned into a kind of scary mistake. Right, exactly. My guess is someone who studied social studies and got offended by similar experiments in social studies with BS papers while being published in reputable journals, right? So let me take a second to talk about one commenter here saying when you say ideally companies should train with data they gained via consent. Okay, so let me take a second here. There's a weird thing that's happening with the AI enthusiast community, and I will acknowledge that I didn't understand how, I guess, this thought process has come up a lot. I still don't fully understand it, right? And I do need to take a second here, right? Because like you're saying things like, how is this fundamentally different than a human going through things? And so what you're fundamentally asking is, how is it different, me reading a book, right, versus an AI scraping my data, not reading the book, not engaging with the content in any way, shape, or form, but just you generating tokens from my work in order to present new data. Like, fundamentally, these are two different things. And it comes with the supposition that AI learns like humans do, which is fundamentally incorrect. Again, I've said this multiple times before, but we don't learn by reading. We learn some, but the way in which we learn is by doing. And this AI is starting to do this a bit with some of the synthetic data and like these thinking models that we were even talking about today with line of thought. What is it? Line of thought thinking, whatever it's called. Like, nowadays, people are recognizing that this is a necessary feature for AI in order to move past whatever level it's at. But like, fundamentally, what AI enthusiasts don't understand is that there is a fundamental difference between companies scraping my data and using it for purposes that I don't really like, and a human using my data for stuff I don't like. A human using my data for stuff I don't want, like, at the very least, they engaged with it. Whereas, you know, a company scraping my data is a fundamentally different thing, right? Like, and I can't express how fundamentally different this is to AI enthusiasts. For me, it's a world apart, you know? Whereas for other people, like people who are AI enthusiasts, they're like, oh, I mean, who cares? You know? And what I realized after posting the video is that there's actually a very big overlap between AI enthusiasts and people who are against copyright in general. And I kind of feel like if I didn't like copyright, I could maybe understand what's coming from here, like where people are coming from, and that, like, you know, my license terms very clearly indicates that I want people to read this, not non-human entities. But let's say it's a more vague license term. Like, I guess I could kind of see it. Like, there's nothing legally wrong with it, but even this still feels like it feels different, right? This is a case where I feel like the laws just need to catch up with the will of the people, and the will of the people, like, I mean, very clearly is not like, I don't know. It's one of those things where, like, I understand that this is a moralistic argument. It is impossible to win a moralistic argument, but even so, there's a very this is a fundamental difference that I just somehow can't explain to people, right? Humans can read a book and learn from it. Humans should not read every Facebook post ever made and learn from it. Even if it's not fundamentally different, it is very different in a practical sense. Chain of thought learning is equal to expanding your worldview. LMs and diffusion models don't have a worldview. They can only replicate patterns from input data, which is infringing even if a human does it. Right, I mean, exactly that. I think that's a fair statement. The main issue with the consent suggestion is trying to address is scraping of content that is publicly available. It was never intended for publication. Also, what Com said, evidence suggests that AI is only remixing its training data, not necessarily learning. Right, but it's not even evidence. We know that it's just remixing data. But again, this is the issue that I have with a lot of AI people. They say AI learns like people do, therefore there should be no issue. But fundamentally, AI doesn't think like people do. Fundamentally, it doesn't learn like people do. Like, it's not like, fundamentally there's an issue with that statement, Like, it doesn't think like people do. Sure, maybe it has similar input sources sometimes, but it's fundamentally, you're asking, why is there a problem when companies are scraping my data without my permission? Like, that's what you're asking. Why is that a problem? In which case, I have no response. Like, how is this okay? You know, like, how is this okay? There's no situation where it's okay. I put MIT licenses on my software, which say any person, you know, like, can use this for any reason, basically. But person is in there. With person, to me, was defined as human entity, right? Any human entity. But I did not give permission for people to scrape that. And so there should be some legal restrictions against people scraping my data in this way. Like, that's what I'm trying to argue. Okay, I'm rambly. I think I'm going to go ahead and leave here. Thank you guys so much for following, like Kitafris and everyone else who followed on today's stream. I recognize it was a little bit long. It was 3 hours and 50 minutes. That's a bit longer than the streams that I typically do. For those who are watching on YouTube and happen to be watching the VOD, I would like to say the following. I do not want to make, or even people who are here right now, there's two things I want to say. One, I don't really want to make a habit of talking about AI much more on this channel. Like, I do it every single stream, and it's very frustrating, right? Today was fine because we're reading papers specifically about AI, and I think that's fine to have discussions about AI while it is on topic. But in cases where it's not on topic, which will be the majority of streams, I just don't see a reason to bring it up. And so if there are discussions on AI that come up, gotta be honest, I'm probably not, I might just briefly comment on it, but I'm not gonna do much more discussions unless there's something really big and beefy to talk about, like on today's stream where we're reading papers and I'm learning more about AI from a research perspective, right? That's fine. Totally fine with that. Okay, the other thing I was going to say is if you're watching the VOD, actually let me know in the comment section what you thought of today's video, and even you guys here in chat, you can do that now. I would like to do more streams and stuff like that where we actually do dissect research and we talk about things. This is stuff that I really like to do. And you saw, I was actually very much enjoying going through the first paper. I hated the second paper, but the first paper was great. I've actually never gotten so angry reading a paper as the second one. And so I'm very interested if you guys are interested in this type of content. I know it's like atypical. It's not what people typically do, but it is one of those things that I very much enjoy. I think other people might as well. Thanks for the stream. No need for more AI engagement unless you want to learn how to make refried beans. But I already make refried beans and I like my refried beans. I don't know. Also, people, if you look up an AI response of how to make refried beans, they probably don't do it the right way because there's multiple different recipes and like, anyway, I'm not getting into that. We're done. Okay, I'll see you next time. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Leos Labs, where we do something. I'm not entirely sure what, but we're going to do something. I don't know when it's going to be. We'll be around. We'll see you. All right, bye guys.